Hello, good evening, students. Good evening, boys and girls. Please respond. Sahil Harsh Thakkar, good evening. Give me the clearance, please. Give me the clearance. Audibility and visibility. Priyanshu, Saxena, Sahil, Sameer, Lona, all clear. तो चलो स्टार्ट करेंगे बच्चों. वेरी गुड इवनिंग टू ऑल ऑफ यू. वेलकम टू अनअकैडमी प्लेटफॉर्म. खलील खान हियर. और आज का हमारा सेशन है एल्गोरिथम PYQ सीरीज. और जैसे मैंने ऑपरेटिंग सिस्टम के सीरीज में आपको बताया था कि one or more topics that we wanted to basically discuss on your emphasization, I would like to basically take up that first. ठीक है. So boys and girls, before we start algorithms, I would like to देखेंगे these are the topics that we are going to cover for algorithms: asymptotic notation, divide and conquer, greedy method, dynamic programming, and some miscellaneous topics. But as I promised, okay, before we start the algorithm session or the questions related to algorithms, I would like to first touch upon the topic which I left over in the last class, or PYQ of operating system, जैसा कि the topic of thrashing. I'll just briefly touch upon it. An important aspect, शायद आपको हो सकता है गेट के एग्जाम में क्वेश्चंस आए based on this. ब्रीफ रिव्यू देखेंगे with regard to thrashing and working set strategy का भी एक ब्रीफ ओवरव्यू दे दूंगा मैं आपको, ठीक है, so that you can have a continue. Celestial Stark, yes, this is algorithm class and we are going to have a brief review of the leftover topic of operating system. उसके immediate बाद हम algorithm start कर लेंगे. चलिए. So thrashing implies excessive or high paging activity. High paging activity. High paging activity का मतलब है page fault rate. Excessive or very high page fault rate. When the page fault rate of the processes shoots up, becomes too high, then that state is called thrashing. आप बोलोगे सर व्हाट इज द ड्रॉबैक ऑफ हैविंग हाई पेज फॉल्ट रेट? जब पेज फॉल्ट रेट बढ़ेगी, CPU is bound to be idle. CPU becomes idle. Why do CPU become idle? Because majority of the processes get blocked. क्योंकि जब आप पेज फॉल्ट सर्विस करोगे, when you are reading and writing the page from disk, the CPU sits idle. Idleness of CPU will lead to low utilization of CPU, low throughput. Hence, in this regard, we say thrashing is an undesirable feature. We never want thrashing to happen. And as a correlation, as an analogy, we just say that just like deadlock is undesirable, thrashing is undesirable. Because when deadlock happens, processes get blocked. When thrashing is too high, page fault rate is very high, processes are in block state, leading to underutilization of CPU. So in that perspective, thrashing like deadlock is undesirable. So before we see how to control thrashing, how to control the page fault rate, we need to identify what are essentially the reasons for the system to thrash. ये page fault rate कब shoot up होगी? What are the reasons, basic reasons for the system to thrash? The basic reasons for the system to thrash are, the fundamental reasons for the system to thrash are, यहाँ पर हम लिखेंगे high degree of multiprogramming. High degree of multiprogramming. When too many processes are injected into the system, right? Chanpreet Singh, when the algorithm topics will start? Yes, maybe after half an hour. Maybe after half an hour, we will start the topics of algorithms. लेकिन ये भी काफी important topic है जो हम पिछले क्लास में complete नहीं कर पाए थे, अब हम complete कर रहे हैं. Based on your demand, I am taking up this. Based on many people demand, I am taking up this. High degree of multiprogramming. This high degree of multiprogramming leading to lack of frames. These are the two basic reasons for the system to thrash. In addition to these reasons, there are other reasons, other factors that contribute to thrashing. What are they? Like for example, we have page replacement techniques. Page replacement policy. That means अगर हम सही page replacement policy use नहीं करेंगे, सही page replacement policy use नहीं करेंगे तो problem हो. It will lead to high page fault rate. Again, I'm telling you, some people are putting the questions in the chat box. For those who are confused that this is operating system but announcement was for algorithms, उनके लिए मैं कह रहा हूँ फिर से एक बार. For those who joined late, last class जो हमारी थी operating system की, some topics were left over and we've said that we are going to cover up those topics first and then I will start algorithm. ठीक है ना? Half an hour maybe 20-25 minutes के बाद algorithm start होगा. ठीक है. So page replacement policy, page size, selection of page size. Smaller page size will lead to more number of pages. More pages matlab more page faults. Less pages matlab less page faults. So therefore, page size will also impact page fault rate. And in addition to that, we have discussed programming techniques and data structures. GATE 2022 में ये क्वेश्चन था, 23 में sorry, programming techniques and data structures. There was a question based on this two-dimensional array था, number of page faults for some given number of frames. For some given number of frames. ठीक है? So that is the factors. तो बच्चों, in addition to that, अगर so what are thrashing control strategies? Orally कह लेंगे. Thrashing control strategies like we have prevention and detection and recovery. Prevention कैसे करोगे आप? By controlling degree of multiprogramming. Right? If you control the degree of multiprogramming, then automatically आपकी percentage utilization of CPU will be under control, will be optimal or will be desirable. वरना अगर हाई डिग्री ऑफ मल्टी प्रोग्रामिंग हो जाएगी, then definitely we'll have problem of page faults. So therefore, by controlling degree of multiprogramming, one can definitely control the page fault rate, and therefore we can prevent thrashing. We can prevent the system from going into thrashing state. Second aspect is go for detection and recovery, reactive approach. तो prevention जब बात करेंगे, that is like proactive. आप सिस्टम को थ्रैश होने नहीं दे रहे हैं, प्रोएक्टिव. रिएक्टिव का मतलब ये है, रिएक्ट सेलेस्टियल स्टार्क. आई थिंक यू आर एन अनफिट पर्सन हियर. डिग्री ऑफ मल्टी प्रोग्रामिंग क्या है अगर आप पूछ रहे हो, तो दैट मींस आई कैन सिंपली से इट्स बेटर यू रिलैक्स, लीव द सेशन एंड रिलैक्स. ठीक है? सो बच्चों, नेक्स्ट रिएक्टिव अप्रोच, ट्राई टू रिएक्ट टू द सिस्टम. ठीक है? सो रिएक्शन मतलब यू बेसिकली detect the system, detect thrashing in the system, and then you try to go for recovery. Detection कैसे करेंगे? High degree of multiprogramming and low utilization of CPU. अगर आपका CPU utilization low हो, high degree of multiprogramming हो, then and page fault, I mean the paging disk utilization is very high. Confirm that system is thrashing. Then how can we recover the system from thrashing? One of the important ways of recovering the system from thrashing is to go for process suspension. ये याद रखिएगा, simple 1 mark question हो सकता है. One simple way of recovering the system from thrashing is to go for process suspension. Swap out the process and swap in the process. Swap out and swap in, right? That is suspension and resumption. Suspend some of the partially completed processes. Create some room in memory. Allow the processes to breathe in. Right? That means have less page fault rate and you continue. So that is the approach of this. इसी zaman, I mean, in this regard, we have a model, we have an approach for controlling thrashing, we have a method for controlling thrashing, and that is called working set strategy. Or working set model. Can you please write down in the chat box and let me know what is the basic principle? What is the basic principle of operation of working set strategy? Can you please write down in the chat box and tell me? What is the basic methodology, the working principle of working set strategy? On what basis, on what paradigm the working set strategy works on? Working set strategy works on, Mohit, please just rewind the tape for a while and try to see why I am discussing operating system in algorithm class. I already mentioned two times why we are discussing operating system in algorithm class. I have already discussed 2 times. I already told 2 times. So again, cannot keep on repeating. So working set strategy is based on the principle of locality of reference. Is based on principle of locality of reference. Locality of reference. Generally, we say that every program will follow a locality model. Locality model का मतलब यह है program is considered to be most of the time divided into localities. Locality may be a function, a procedure, a block, or some data structure. So the basic core idea is try to estimate the locality in which the program is currently executing and demand the operating system for those many frames. अगर आपकी locality की size 5 pages हो, you should ask for 5 pages, 4 pages, or 4 frames, 5 frames or 4 frames. Are you getting my point? So demand for those many frames, not the 50% rule or proportionate allocation or equal allocation. Demand. So this is like a dynamic approach. So based on the size of locality, you are going to ask the operating system for those many frames so that memory utilization will be better, and at the same time the page fault rate is under control. But the major challenge here is how do we estimate the size of locality? How do we estimate the size of locality? One approach is to apply a concept called working set window. Working set window मैंने अपने classes में बताया था आपको. Use the working set window concept, estimate the size of locality, and then you demand for those many frames. And second point, based on the working set window, you try to find the total demand from all the processes put together. If the total demand for frames by all the processes is within the acceptable limit, then we say the system is not thrashing. But it has increased beyond the number of frames available, then definitely system is thrashing. When system is thrashing, you have to again go for process suspension. So this is the basic core idea. अब चूंकि हमारे पास उतना टाइम नहीं है, इसलिए मैं प्रॉब्लम वर्किंग सेट पर नहीं ले रहा हूं. हाँ, एग्जाम से पहले अगर मुझे कोई अपॉर्चुनिटी मिलेगी कुछ सॉल्व करने की, तो मैं वर्किंग सेट का प्रॉब्लम सॉल्व करूंगा. नहीं तो you can, those who are my paid batch students, you can see in my video I have solved couple of questions on working set window. ठीक है ना? तो based on thrashing and working set window we will confine ourselves to this point. अब एक प्रॉब्लम हम सॉल्व करेंगे विथ रिगार्ड टू सेगमेंटेड पेजिंग, जैसा कि कई बच्चों ने पूछा था. सेगमेंटेड पेजिंग का एक प्रॉब्लम सॉल्व करूंगा, फिर उसके बाद हम एल्गोरिथम स्टार्ट करेंगे. बच्चों ये क्वेश्चन है, देखिएगा. सबसे पहले आपको बता दूं व्हाई शुड वी गो फॉर सेगमेंटेड पेजिंग. फिर से एक बार रिपीट कर रहा हूं, एल्गोरिथम परहैप्स विल स्टार्ट विद इन 10-15 मिनट्स. एक प्रॉब्लम जो आपने डिमांड किया था सेगमेंटेड पेजिंग का, वो वर्कआउट कर लेंगे, फिर एल्गोरिथम स्टार्ट करेंगे. चलिए देखिएगा बच्चों. So point number 1, why should I go for segmented paging? We are introducing paging into segment because paging is a concept which can be applied onto several address spaces. Like it can be a virtual address space, it can be a page table address space, or it can be any other address space. Segmentation we saw suffers from external fragmentation, where it occurs in physical address space, right? Physical address space. Right, it occurs in physical address space. तो अगर आप segmentation policy में segmented policy में external fragmentation नहीं चाह रहे हो, then I can go for compaction. लेकिन compaction is not a desirable solution. So when it is not desirable solution, then what is the other approach? The other approach is to go for paging. So one aspect of introducing paging into segmentation policy is apply paging on segment. You divide your segment. Listen to me carefully बच्चों जो interested है, क्योंकि ये क्वेश्चन अब तक ये कॉन्सेप्ट पर न्यूमेरिकल क्वेश्चन नहीं आया है. हो सकता है 2024 में आपको एक न्यूमेरिकल क्वेश्चन आए ऑन सेगमेंटेड पेजिंग. तो प्लीज वो प्रॉब्लम मैं सॉल्व कर रहा हूं, अगर आप समझ जाओगे तो perhaps you can fetch 2 marks. Let us imagine. So take some segment, whatever is the segment size given, apply paging on it, divide the segment into pages. Store the pages of segment in frames of memory, and finally access the pages of segment through page table. बच्चों एक बात हमेशा याद रखिए जो मैं अब कहता हूं when I teach in my paid batches or maybe revision batches, कि wherever you applying paging, जहां पर भी आप paging apply कर रहे हो, you need a page table to access the pages of the address space. अगर आप paging virtual address space पर apply कर रहे हो, then I need a page table to access the pages of virtual address space in frames of memory. उसी तरह पेजिंग जब हम सेगमेंट पर अप्लाई करेंगे, then I need basically a page table to access the pages of segment. pages. So this is one aspect where we can apply paging on segment. Second domain where we can apply paging is if segment table become large. Listen to me, there were questions in GATE based on this. अगर आपका segment table बढ़ जाए, काफी बड़ा हो जाए, then you can reduce the size of the segment table overhead by applying paging onto segment table, so that I can have reduced size of segment table kept in, reduced size of the space overhead, or I can reduce the size of the space overhead of segment table by having a smaller page table with the associated with segment table. So there are two aspects. One is paging on segment to overcome external fragmentation. Second aspect, paging on segment table to reduce the space overhead. That's it. These are the reasons. तो ये क्वेश्चन में, ये प्रॉब्लम में देखेंगे हम, इंपॉर्टेंट प्रॉब्लम है बच्चों. हो सकता है गेट एग्जाम में आपको ये क्वेश्चन आए. आई एम टेकिंग दिस क्वेश्चन फ्रॉम विलियम स्टैलिंग्स, सो प्लीज फॉलो मी केयरफुली. Consider a system using segmented paging architecture with virtual address space, physical address space of 2 power 16 bytes. The virtual address space is divided into 8 equal size segments, non-overlapping segments, like independent segments. तो यहां पर अंडरस्टैंड करेंगे. तो फॉर एग्जाम्पल, इफ आई इमेजिन दैट दिस माई सेगमेंट, as per the given condition, the whole virtual address space of size 2 power 16, यहां पे लिखेंगे 2 power 16 is divided into 8 equal size segments. So if I divide 2 power 16 by 8, this will give me segment size. ये जो segment है इसकी size मिलेगी मुझे, क्या होगी? 2 power 16 bytes, yeah, divided into 8. So 2 power 16 by 2 power 3, that become 2 power 13. 2 power 13 is equal to 8 KB. तो ये जो segment हमारा है इसका size है 8 KB. First step. So please follow carefully, please. बच्चों carefully follow कीजिएगा. So I got the segment size. Look at that, it is very clearly given. Paging is applied on segment with the page size being a power of 2. Page size power of 2 है. The page table entry size of the page tables of the segment is 16 bits. 16 bits मतलब 2 bytes. So entry size is 2 bytes of the page table. What must be the page size of the segment such that the page table of the segment exactly fits in one frame of memory or one page frame? ठीक है ना? So that means we have divided this. Listen to me carefully and follow carefully, please. We have divided this segment into pages. Page size as what? So यहाँ पर page size हमें determine करना है. So let us say let page size of segment is equal to 2 power x bytes. Let us say page size of segment is equal to 2 power x bytes. So this is 2 power x bytes. So how many pages will I get in the segment? Size of the segment 8 KB divided by 2 power x. These 2 power 13 minus x. These are number of pages in the segment. These are number of pages in the segment. ठीक है ना? These are number of pages in the segment. तो जैसे मैंने कहा, when I apply paging on segment, the pages of the segment, these page 0, these page 1, these page 2, whatever pages you want, they will be stored in frames of memory. And to access the pages of the segment in frames of memory, I need a page table. This page table of segment, हर segment का अपना page table होगा. ये page table of segment. बच्चों बताइए golden rule क्या है page table of segment और page table organization का? Number of entries in page table. Listen to me. The number of entries in page table is always equal to number of pages. How many pages I have? 2 power 13 minus x. So number of entries here are 2 power 13 minus x. Number of entries. And entry size is already given 2 bytes. ये जो entry size है 2 bytes है. So therefore from this discussion what should I conclude? I should conclude page table size. Page table size equal to number of entries 2 power 13 minus x multiplied by entry size 2 bytes. This become 2 power 14 minus x bytes. So boys and girls, this is the size of page table. Boys and girls, please follow me. This is the size of page table. ये page table का size मिला आपका. And he is saying in the question that this page table, what must be the page size? What must be this page size 2 power x of the segment such that the page table of the segment, ये page table, should exactly fit in one frame of memory or one page frame. Page frame का size क्या होगा? 2 power x. तो मतलब ये जो size है आपका page table, this should fit in one frame of memory. So that means very clearly this value should be equated 2 power 14 minus x is equal to 2 power x. So solving for x from here implies 2x is equal to 14, x is equal to 7. So x is equal to 7, page size हमने 2 power x माना, so 2 power 7 bytes, which is 128 bytes. So therefore, the answer for this question is page size is equal to 2 power 7, 128 bytes. ये है आपका आंसर, 128 bytes. Got it? So the answer for this question is 128 bytes. That's how we solve. Similar to this concept, बच्चों, मैं आपको थोड़ा आज के लिए ही होमवर्क दे रहा हूं, थोड़ा वर्कआउट करने के लिए. नेक्स्ट क्वेश्चन, दिस इज अ सेकंड अनदर क्वेश्चन ऑन segmented paging. I am leaving this for you to work out. End of the class I will try to work out this. End of the class I will try to work out. I am giving you this for current homework. Current homework means right now in this session you have to work out. This is also a question on segmented paging, same thing, right? So ये मल्टी लेवल पेजिंग का क्वेश्चन हमने देखा था, लेकिन कुछ बच्चों ने डिमांड की थी ये क्वेश्चन के लिए. देखिएगा ये क्वेश्चन, ये क्वेश्चन अभी 2 मिनट में हम स्टार्ट करेंगे. एल्गोरिथम 2 मिनट में स्टार्ट करेंगे. Some people have asked me to take up this question of multi-level paging. So shall we solve or shall we solve after some time? बोलिएगा. This is a star question of multi-level paging where generally people have a doubt. ठीक है ना? We'll solve. I mean, I will give you some time for you to think it over about this question. And then you realize what should be the answer for it. Then I will take up this discussion maybe in the middle of algorithms or maybe at the end of algorithm. ठीक है ना? Maybe at the end of algorithm I will take up this, because many people are demanding for starting algorithm. I will start algorithm first, and I promise I will solve this. We'll solve this question. We'll solve in today's session only. We'll solve it. ठीक है? Maybe after some time we'll solve. Meanwhile, till that time you can try. Till that time you can try. चलिए बच्चों, अब हम स्टार्ट करेंगे क्वेश्चंस फ्रॉम एल्गोरिथम्स. एल्गोरिथम से स्टार्ट करेंगे, स्टार्टिंग विथ एसिम्प्टोटिक नोटेशंस. एसिम्प्टोटिक नोटेशन से. सो स्टार्टिंग विद अ वेरी फर्स्ट सिंपल क्वेश्चन. प्लीज टेल मी व्हाट इज आंसर फॉर दिस. प्लीज टेल मी व्हाट इज आंसर फॉर दिस. व्हाट डू यू मीन बाय स्टार्टिंग लास्ट से कराना? आई डिडंट गेट योर पॉइंट. Somebody is saying an unusual remark. How can we start from last? What do you mean by Guddu Lavanya? Start from last. What do you mean by that? Last in, first out? Last chapter से कराएंगे तो that you won't get. क्यों last में कराएंगे? Asymptotic notation is one of the very important topic. रिवर्स ऑर्डर में मतलब कौन सा चैप्टर पहले कराएंगे? come on, that's waste of time. Asymptotic notation is a very important topic and we cannot compromise on it. So let us quickly start from this. Let W of n and A of n denote respectively the worst case and average case running time of an algorithm executed on an input of size n. Which of the following is always true? W of n and A of n. I already told the relation between them is that the best case time is less than or equal to average case time less than or equal to worst case time. So average time is omega of W of n. This is not always correct, right? Average is not always correct. Average is equal to order of W of n. This is always true. This is always true. This may not be always true. This is not always true. So therefore the correct answer is C. Chaliye, next question. Many people go wrong with this. Tell me the answer. GATE 2021 का question है. Come on. What is the answer for this? Guddu Lavanya, you were saying overconfidently start from last, but your answer is wrong. Guddu Lavanya, your answer for this question is wrong. This question. Tell me what is the answer for this. Whenever there is a confusion, you are supposed to take the log. If I take log of this, this will become n into log 10. Let's say some base 2. This will become log n into log n whole square. The third will become root n into log n. Right? So smallest is this. And so this is the smallest, F2. This is now F3. And this is F1. So F2, F3, F1. The correct option is D. Very correct. So I'll slightly go fast with regard to simple question. ये भी बहुत simple question है. We did that earlier. This is also a simple question. We did that earlier if you remember. So I will not touch upon this. ये देखेंगे please. Based on trichotomy property, look at this problem. Based on trichotomy property, I will ignore simple questions. I will take up more interesting questions. Tell me the answer for this. Come on, boys and girls. F of n is n. G of n is equal to n power 1 plus sin n, where n is a positive integer. Which of the following statements is or are correct? True or correct? Come on, tell me. True or correct? Yes. This is based on trichotomy property. This is based on trichotomy property, which say that given two real numbers are always trichotomy. A is less than b or greater than b or equal to b, but that does not apply for asymptotic functions. That does not apply. So therefore, neither of them are true. Neither f is order of g or g is order of f asymptotically. So therefore, that is not correct. Tell me the answer for this question, bachcho. Work out this. You need to make some computation in this question. Tell me what is the answer for this. Come on, हो सकता है आपने किया होगा या ना किया होगा, but still you can work out and tell me what is the answer for this question. Come on. Is it C or D? Is it C or D, boys and girls? I'll explain this question diagrammatically. Please try to understand. There is some database which has got n equal to 10 power k records. 10 power k records. Two packages matlab two algorithms. Package A and package B. Algorithm A and algorithm B. The time taken for package A is 0.0001 n square, and that of B is 10 into n into log n. Base of log is 10. Right? He's saying, so boys and girls, here I would like to tell you, if you just take the asymptotic order of this, the order of this is order of n square, and the order of this is order of n log n. So definitely we would say that package B is better than package A in terms of time complexity, in terms of performance. The time of package B is n log n, this is n square. So naturally B is better than A. लेकिन यहाँ पर ये पूछना नहीं जा रहा है कि which is better. He is saying what is the smallest value of k, this k, for which package B is preferred over package A. Matlab, because of this constant is going to play a role for some time. Because of this constant. Because this is a very small value, 10 power minus 4. So 10 power minus 4 for smaller values of n will dominate, and as a result package A may take less time than package B realistically. Package A may take less time than package B. So that's what I'm asking here. For what value of n, for what value of k, n equal to 10 power k, for what value of k, package B starts performing better than package A. Package B starts performing better than package A. You cannot keep on substituting the values and do it. So here we have to work out directly. So we want the value 10 into n into log n to base 10 should be less than 0.0001 n square for n is equal to 2 power k. So what is that value of k which will make this perform better than? Perform better than means should take lesser value than this. So directly substitute कीजिएगा 10 into the value of n is 2 power 2 power k, 10 power k है, 2 power k है, 10 power k. So we'll write 10 power k. N is equal to 10 power k. 10 power k. So this is 10 into 10 power k into log of 10 power k to base 10 less than 0.001 means 10 power minus 4 into 10 power k whole square into whole square. ठीक है ना? तो देखिएगा प्लीज. So if you simplify this, so this will become, so this 10 power k will cancel with 1 10 power k, so I will have 10 power k here, and this will become k, so k into 10 should be less than 10 power k divided by 10 power 4. So the value of k should be less than 10 power k, I bring this 10 to this side, other side, so it will become 10 power 5. So that means I need to work out here in this inequality, equation 1, to find that k which satisfy this inequality. What is that smallest k which satisfy this inequality? अगर k की value of 5 लोगे, 5 is less than 1, no. 6 लोगे, 6 is less than 10, yes. So therefore, the smallest value of k for which it satisfies k is equal to 6. K is equal to 6. I hope you are understanding. So therefore, the answer for this problem is C. It is not 5. It is not 5 as you have seen. तो मतलब ये है for up to 10 power 1, 10 power 2, 10 power 3, 10 power 4, 10 power 5, package A will be better than package B. Package A will be better than package B. तो जैसे ही k की value 6 होगी, 10 power 6, then package B will start taking less time than package A. ये मतलब है. Got it now? Very good. चलिए अब थोड़े लूप के ऊपर क्वेश्चन लेंगे. जनरली आई हैव सीन मेनी पीपल हैविंग ए बिट ऑफ स्ट्रगल विथ लूप्स. तो कुछ लूप के क्वेश्चंस लेंगे यहां पर. इसका आंसर जल्दी बता दीजिएगा बच्चों. प्लीज टेल मी द आंसर फॉर दिस. Bhargav Patel, you have not understood the question. Please read the question again. Bhargav Patel. Bhargav Patel rather. आप क्वेश्चन नहीं समझे. Read the question again. What is the answer for this, boys and girls? Very simple. Some people are saying A, some people are saying B. चलिए start करेंगे. This loop is definitely repeating for n by 2 times. N by 2 to n, incrementing by 1. J is equal to, so this is log n time. Right? And k is initially 0, 0 plus n by 2. So n by 2 plus n by 2 plus n by 2. So it become n by 2 log n. The value of k at the end of first iteration will be n by 2 into log n. ये जो आप iteration करोगे आप, the value of k will be n by 2 log n. Am I right? Value of k is asking, not time complexity. Value of k will be n by 2 log n after completing this loop. Lekin this loop is repeating for how many times? N by 2 times. This loop is being repeated for how many times? N by 2 times. तो मतलब कितने बार आप increment करोगे? So you have to multiply this with n by 2. So it will become n square by 4. The value of k will be finally n square by 4 into log n. So if you take the asymptotic order or omega of it, n square log n, so the option B is correct. Option B is correct. लेकिन बच्चों अगर value of k के बजाय अगर मैं पूछता आपको what is the time complexity of this algorithm, then what is the answer for it? अगर if you would have asked what is the time complexity of it, हाँ बोलिएगा बच्चों. If I would have asked what is the time complexity of it, what is the time complexity of this, then what will you say? Come on. The time complexity of this is what? Yes, the time complexity. देखिएगा, time complexity does not depend on this increment operation, right? So n by 2 के ऊपर depend नहीं करेगी. You have to multiply these two, n by 2 into log n. So time complexity is order of n log n. Time complexity is order of n log n. चलिए नेक्स्ट क्वेश्चन पे जाएंगे. इसका आंसर दीजिएगा. ये भी बहुत इंटरेस्टिंग क्वेश्चन है. टेल मी द आंसर. आई विल जस्ट गिव यू 2 minutes of time. I will give you 2 minutes of time. Tell me the answer for this. चलिए बच्चों स्टार्ट करेंगे. व्हाट इज आंसर? व्हाट इज आंसर फॉर दिस? Come on. This is a PYQ asked in 2015. So let us proceed for this. Which one of the following closely approximate the return value of the function? Return value is asking. What is returning? Returning Q. So देखिएगा बच्चों, this loop is repeating anyway for n times. P is 0. So this is log n, right? The value of P will be log n. The value of P will be log n. It is log n loop. And K is repeating up to P. P means log n. So again this is log n. Log P matlab log n. This is log n. I hope you are understanding. So log n. So first iteration the value of Q will be log n. Again it increments from log n. Again it increments from log n by another time, right? 2 times log n, 3 times log n, 4 times log n, n times log n. I hope you are able to understand this, right? So therefore the answer for this is D. Answer for this is D. लेकिन एक यहां पर एक क्वेश्चन पूछूंगा मैं, देखेंगे कौन रिस्पॉन्ड करेगा. as a matter of change, along with P equal to 0, if I would have written Q also equal to 0, जब क्या कोई बताएगा what would be the answer? Please tell me. If I would have written Q also equal to 0 here, then what would have been the answer? If I would have written Q also equal to 0, then what would have been the value of Q? What would have been the answer? What would have been the value of Q? Can anybody tell me? If I make Q also equal to 0 in every iteration, yes, then now the value of Q, then the value of Q will be log n, only log n, one time. That's it. That's it. So I hope you are able to understand. Lastly, I ask another variation. Please answer me. Lastly, I ask another variation. What is the time complexity of this algorithm? Boliye. What is the time complexity of this algorithm? Come on, tell me. The time complexity. If time complexity would have been asked, what is the answer for it? What is the answer for it? See, this is done n times total, repeating for n. This is repeating for per iteration log n times it is repeating. So therefore, this loop will repeat for n log n. And this will repeat for n into log n, n into log n. So overall time complexity would become n into log n. That's the difference between time complexity and the value of k. So time complexity is n log n, the value of k is n log n. So be very careful. That is a very important aspect. Come on, tell me the answer for this. This loop is also important. Many times I saw people going into confusion. So can you please tell me what is the answer for this loop? इसकी time complexity बताइएगा please in terms of theta notation. Come on fast. Boys and girls, this is PYQ. I am assuming that you have done enough revision of PYQ. You should be able to work out fast. You should be able to work out fast. Come on, so that we can concentrate on other problems. जल्दी जल्दी कीजिएगा. देखिए, outer loop is undoubtedly repeating for n times. J is equal to 1, J is less than or equal to n, also you can put nothing wrong. And J is equal to J plus I. It is not J equal to J plus 1. J is equal to J plus I. तो मतलब first time I will be 1. So this will repeat for, if you do unfolding process, अगर आप unfolding process करोगे, first time it will repeat for n. Next time it will repeat for, देखिएगा, J is equal to J plus 2, मतलब n by 2 times. Next time it will repeat for n by 3 times. Next time it will repeat for n by 4 times, plus so on, plus n by n times. So n by 1 plus n by 2 plus n by 3 plus so on n by n. So n is common. It is sigma 1 by x, x going from 1 to n. X going from 1 to n. This summation series is nothing but log series. So therefore this is n log n. Therefore the correct answer is C, n log n. Krishan Kumar is saying B. How is it B? Patel Swayam is saying A. How is it A? Check it. This is a very simple series. Unfolding, जहां पर भी आपको confusion हो, unfolding process is the simplest. Unfolding का मतलब क्या है? First iteration में क्या हो रहा है? सेकेंड आइट्रेशन में क्या हो रहा है, थर्ड आइट्रेशन में कितने टाइम एग्जीक्यूट कर रहा है, दिस यू हैव टू राइट. First iteration it is repeating by n by 1, next iteration n by 2, next iteration n by 3, n by 4 up to n by n. Add them, that's it. That is the total number of time the loops have repeated. That's all. Next. हाँ, ये एक इंपॉर्टेंट क्वेश्चन है, इसे डिस्कस करूंगा. देन फाइनली कैसे वर्कआउट करना है आप बाद में इसे वर्कआउट कर सकते हो. आई वांट एवरीबडी टू प्लीज रीड दिस क्वेश्चन. आई वुड कंसिडर दिस एज ए स्टार टॉपिक, स्टार क्वेश्चन. Come on. I would consider this as a star question. Tell me, read the question first, then we'll have a discussion. I would say this is a combination. This question is a combination of data structures plus algorithms. Algorithm में analysis की topic. Data structures plus analysis. Asymptotic analysis. बोलिएगा. Read the question. This type of questions are important. An algorithm performs root log n find operations, n insert operations, root log n delete operations, and root log n decrease key operations. Itne operations on a set of data items with keys drawn from a linearly ordered set. For a delete operation, a pointer is already provided to the record that must be deleted. For the decrease key operation, a pointer is provided. मतलब delete और decrease key के लिए एलिमेंट जो डिलीट करना है और डिक्रीज की करना है उसके लिए पॉइंटर प्रोवाइडेड है अमंग द लिस्ट ऑफ एलिमेंट्स. ठीक है. विच वन ऑफ द फॉलोइंग डेटा स्ट्रक्चर्स इज द मोस्ट सूटेड फॉर द एल्गोरिथम टू यूज इफ द गोल इज टू अचीव द बेस्ट टोटल टाइम मिनिमम टोटल टाइम कॉम्प्लेक्सिटी. ये सारे ऑपरेशंस ऐड करके मिनिमम टाइम कॉम्प्लेक्सिटी कौन सा डेटा स्ट्रक्चर प्रोवाइड करेगा. चलिए स्टार्ट करते हैं. सबसे पहले अनसॉर्टेड अरे. वी हैव एन अनसॉर्टेड अरे. सेकेंड क्या है, हीप है, मिन हीप. थर्ड है सॉर्टेड अरे. नेक्स्ट है सॉर्टेड डबली लिंक लिस्ट. तो दो चीजों के लिए हम डिस्कस करेंगे, बाकी का फिर आप कर सकते हो. चलिए यहां पे चैट बॉक्स में मुझे लिख के बताइएगा बच्चों, चैट बॉक्स में लिख के बताइएगा. नाउ डिलीट, यू आर हैविंग एन अनसॉर्टेड अरे. यू आर हैविंग एन अनसॉर्टेड अरे. फर्स्ट ऑपरेशन इज बेसिकली फाइंड ऑपरेशन. look at that. When I'm having an array with n elements, listen to me carefully. When I'm having an array with n elements, what is the time complexity to find a particular element when the array is unsorted? कितना टाइम लगेगा एक फाइंड ऑपरेशन के लिए कितना टाइम लगेगा, बोलिएगा प्लीज. फॉर वन, जस्ट राइट डाउन इन द चैट बॉक्स. आई एम नॉट आस्किंग अबाउट द आंसर. आई एम डूइंग एनालिसिस. प्लीज फॉलो मी. आई एम डूइंग द एनालिसिस. सो फॉर अनसॉर्टेड अरे, आई एम जस्ट डूइंग इट फॉर अनसॉर्टेड अरे. फॉर अनसॉर्टेड अरे, what is the time for find operation? Find operation कितना लगेगा? Find operation लगेगा order of n. I will have to have worst case for order of n. Total find operations कितने हैं देखिएगा. Total find operations are how many? Root log n. तो एक find के लिए order of n, root log n के लिए कितना टाइम लगेगा? n into root log n. This will be the total time. सेकेंड ऑपरेशन जो हम परफॉर्म कर रहे हैं अनसॉर्टेड अरे पर, इंसर्ट ऑपरेशन. देखिए अरे इज अनसॉर्टेड, तो यू कैन इंसर्ट एट एनी प्लेस लाइक फर्स्ट पोजीशन, और यू कैन इंसर्ट एट द लास्ट पोजीशन. एट रैंडमली एनी पोजीशन यू कैन इंसर्ट बिकॉज अरे इज अनसॉर्टेड. सो देयरफॉर इंसर्ट, इफ यू डायरेक्टली मिनिमम टाइम अगर चाह रहे हो आप, then basically I can put it at the end in just order of one time. So overall time, how many insert? N insert. So therefore total time will become n into order of 1, n order of n. Insert, one insert will take order of 1, n insert will take total n. चलिए नेक्स्ट ऑपरेशन क्या परफॉर्म कर रहे हैं हम. व्हाट इज द नेक्स्ट ऑपरेशन? डिलीट ऑपरेशन. डिलीट यहां पे देखेंगे कौन बताएगा. In an unsorted array having n elements, again I'm repeating, in an unsorted array having n elements, and the element which you want to delete is already pointed by a pointer, then what is the time complexity to delete that element? What is the time complexity to delete that element? Tell me please. Tell me, what is the time complexity for one delete operation? एक delete operation के लिए कितना टाइम लगेगा? List is unsorted. People may generally here go confuse and say order of n. आप देखिए एलिमेंट्स मूव करने की जरूरत नहीं है, एलिमेंट्स मूव करने की जरूरत नहीं है, you can simply swap with last element and then delete that element or remove that element as it is. That's it. You can swap with the last element and delete. So in order of 1 you can do. So order of 1 you can do, and the total time, how many deletes are there? Root log n. So therefore total time will become root log n into 1. Root log n into 1. Next, which operation are we performing? Delete के बाद decrease key operation on a set of data items. Decrease key ऐसे लिखेंगे, right? So how many decrease key are being performed? Root log n decrease key. So again this will take only one time. Just I have to decrease the key because the list is unsorted. I don't have to really maintain the sorted. So therefore for one operation it is order of n. For root log n it will be again root log n into 1. So this is my total time of performing all the operations. N root log n into 1, root log n plus root log n. So if I add up and take the asymptotic time in order of magnitude of the leading term is n into root log n. Matlab to complete all these operations by using unsorted array as a data structure, my total time taken will be n into root log n. Am I right? N into root log n. इसी तरह you will have to repeat with min heap. जैसे कि heap में अगर find operation, you will have to search for the entire heap. If you want to perform an insert operation, order of 1 के बजाय order of log n लगेगा. A delete operation, order of log n लगेगा. Decrease key can also be done in order of log n time. तो उसी तरह heap का आपको करना है. उसी तरह doubly linked list sorted array के लिए भी आपको repeat करना है. And then you have to see among all the 4 data structures, which data structure is eventually taking total less time. So when you do it like this, you will find that unsorted array eventually, people generally think heap will take less time, or maybe sorted doubly linked list may take less time, but eventually if you do in the method which I outlined, you will find that unsorted array will take less time. To complete all these operations, unsorted array will take less time. So therefore, decrease key operation means a particular element is there, you are decreasing its value, that's it, decrease key. What is decrease key operation? You are asking just 3 days before the GATE exam. So I am getting surprised whether are you really a GATE aspirant or not. Is it not? Yes, sorted array will take more time because find operation of in sorting array may be less, but other operations like insert operation will take more time. Right. चलिए इसका आंसर जल्दी बता दीजिएगा प्लीज. मैचिंग पेयर है. This is a matching pair question. This is a matching pair. Towers of Hanoi, the time complexity of this is 2 power n. Binary search log n. Right? Heap sort given n numbers in the worst case n log n. Addition of 2 matrices n square. So that's it. All the options are there. You can comfortably match it. There is no confusion at all. So one of the options will match. We'll directly go. इसका भी जल्दी oral बता दीजिए मुझे answer, because sometimes I told you have to remember the answers for these type of questions. इसके लिए मैं यहाँ पर लाया हूँ. Do you remember what is the answer for this without working out? अगर ऐसा question अगर गेट में अगर आए तो in order of one time you should solve. In order of one time, not order of n also, not order of log n also, order of 1. Order of one time में solve करने का मतलब ये है कि such questions you should work out directly without making any computation. Tell me what is the answer of this? Shrishti Chaudhary, it is not order of log n. Be careful. Oh my God, people are making mistake. इसीलिए मैं क्वेश्चन यहां पर लेकर आया हूं. अगर ये 2 ना होता यहां पर, then answer is log n. Because of this 2, it will become order of log n. It is order of log n. So be careful, boys and girls. It is order of log n. So you have to be careful with these type of questions. Come on. इसका जल्दी आंसर बताइएगा. उसका प्रीवियस क्वेश्चन का वेरिएशन है. इसका आंसर बताइएगा प्लीज. Recurrences. Question based on recurrences. Come on. No problem. Continue and tell me the answer for this, boys and girls. Then important question. For parameters A and B, both of which are omega of 1, T of n is equal to T of n power 1 by a plus 1, T of b is equal to 1, then T of n is dash. What is the answer for this? What is the answer for this? ये solve करूंगा मैं, देखिएगा please. If you go with back substitution, T of n is equal to T of n power 1 by a plus 1. If you find the value of n power 1 by a on equation right hand side, it will become T power n power 1 by a whole raised to 1 by a plus 1 it become 2. So this will be written as T of n power 1 by a square. ठीक है ना? 1 by a square plus 2. Next level of substitution अगर आप करोगे, it will become T of n is equal to T of n power 1 by a cube plus 3a. अगर आप इसी तरह सब्स्टिट्यूट करते जाओगे, at one level it will become a power 1 by a power k plus k into a. ऐसे बनेगा. Such that this should get annihilated. This whole term should get annihilated. मतलब n power 1 by a power k should become initial condition. Initial condition देखिएगा यहाँ पे दिया गया है T of b. मतलब this should become b. This should become b. So if you take log of this, it will become 1 by a power k into log n is equal to log b. So a power k, if I bring the other side, I can write a power k as log n to base b. I hope you agree with me. Right? ठीक है? A power k is equal to log. So if you find the value of k from here, it will be log n, log of a into log of n to base b. Log n of, not into, log n of, log of log n to base b and this whole to base a. It will, k will be simplified like this. ठीक है? Come on. Some people are totally ignorant and trying to attend the class. यहाँ पर 2 आया तो यहाँ 3 कैसा? 3a नहीं है, sorry. So I'm sorry. This is just 3. This is just 3. This is just k and that is 3. That's right. Got it? तो देखिएगा k की वैल्यू आपको आ गई है. So therefore this is nothing but 1. And this is nothing but k. K is nothing but log a of log n to base b. If you take the order, this is the order. So therefore the answer is b. The answer is b. I hope you got it. This is the way you simplify. चलिए नेक्स्ट जाएंगे. डिवाइड एंड कॉन्कर के थोड़े क्वेश्चन लेंगे जल्दी. मास्टर मेथड के ऊपर एक क्वेश्चन है बच्चों, बता दीजिएगा. सी वेदर यू रिमेंबर इट और नॉट. सी वेदर यू रिमेंबर इट और नॉट. मास्टर मेथड का क्वेश्चन है. मास्टर मेथड का क्वेश्चन है. मास्टर थियरम या मास्टर मेथड. फॉर कॉन्स्टेंट्स a greater than or equal to 1, b greater than 1, consider the following recurrence a t n by b plus f of n. Which one of the following options is correct about the recurrence t of n? Master method. So this is theta case. If f of n is theta of n power log a to base b, then t of n is, this is not correct. This is not any case. F of n is order of n power log a to base b minus epsilon. For some epsilon greater than 0, then t of n is theta of n power log a to base b. नहीं होगा. Theta of n power n power log a to base b. So that is option B. Option C, this is not any case. Option D, if f of n is n log n, ये भी कोई case नहीं है. So therefore what is the correct answer? Many people are saying option B is correct. Option B is correct. चलिए next. जल्दी master method से apply करके बता दीजिएगा what is the answer for this. By applying master method, please tell me which case apply on to this. मुझे case बोलिएगा, case 1, case 2 और case 3. Case बोलिएगा please. And then you can tell me the answer by that case. Which case apply? For this recurrence, which case apply? For this recurrence, which case apply, boys and girls? I'm asking case number. Is it A, case 1 or case 2 or case 3? Is it case 1 or case 2 or case 3? बोलिए. Is it case 1 or case 2 or case 3? Come on, this is very simple. It should not take so much time. Case 3. Because the value of A is 1 here. The value of A is 1. Right? So log of f of n is Cn. Cn is it order of n power log a to base b is 0 minus epsilon. Is this possible? No, this is not possible. Because this value is greater than this. Cn, is it theta of n power log a to base b into log n power k. This is not also possible. Checking for case 3, Cn, is it omega of n power log a to base b 0 plus epsilon? Yes, for epsilon equal to 1, perfectly satisfying. The value of delta will come out to 1 by 3, which is less than 1, perfectly satisfying. So by case 3, it is theta of n. Answer is A. Absolutely correct. Answer is A. उसी तरह जल्दी इसको बताइएगा बच्चों. For this one, which case apply? Tell me the case number. Tell me the case number. Which case apply for this recurrence? This is only practice for master theorem. Which case apply for this? 2tn by 2 plus log n. 2tn by 2 plus log n. Which case apply for this? Yes. Tanuja Sahu is correct. This is case 2. Very good. So by case 2, which one? What is the correct answer for this? What is the correct answer for this? बोलिएगा. Case 1 or case 2? So you're saying case 2. Let us apply. Log n. Is it order of n power log a to base b 1 minus epsilon? Tell me. Yes, for epsilon equal to 0.5, if you take it is satisfying. So it is not case 2, it is case 1. It is case 1. Please understand, it is case 1, not case 2. Case 1 satisfy हो रहा है. Log n is less than root n. Log n is less than n. Log n is under log n. Under n. So therefore, by case 2, option is A. By case 1, option is A. Not B, please. अगर ये log n की जगह n होता, जब option B होता आंसर. If it is n, then option will be B. It is n log n, so therefore option is n. Ion Debian. Now I am telling your name. क्या बोलना चाह रहे हो आप? Ion Debian. बोलिए. चलिए नेक्स्ट. ये छोड़ दिया, सिंपल है. ये भी सिंपल है, कर सकते हो आप. इसका जल्दी बता दीजिएगा आंसर प्लीज. टेल मी द आंसर फॉर दिस क्वेश्चन. Tell me the answer for this question, boys and girls. अच्छा. Ion Debian is right. So very good, Debian. I'm clapping for you. Be happy. Okay. Ion Debian has given correct answer. Please congratulate him, please. He wanted to get motivated before the exam. Come on. Tell me the answer for this. Very simple. What is the number of swaps required? Remember, selection sort is the only sorting technique which has the least number of swaps in the worst case. In the worst case, it has the least number of swaps. So what is that? The answer is order of n. Merge sort के number of swaps बनेंगे n log n in the worst case. Quick sort order of n square. Heap sort n log n. ठीक है, worst case में. लेकिन selection sort की property है. Insertion sort order of n square. लेकिन selection sort की complexity है order of n as far as swaps are concerned. So the answer is A. Answer is A. चलिए इसका आंसर बता दीजिएगा प्लीज. Tell me the answer for this question. Yes, I will tell. You give the answers, I will tell your names. Come on, don't behave like children. Come on, tell me the answer for this. The worst case running time to search for an element in a balanced, look at that, यहाँ पर balanced word use किया गया है. अगर balanced हो गया है तो आपको time complexity लगेगी order of log n. With number of elements are this. So when number of elements capital N, then the time complexity for balanced tree for locating or searching for an element is order of log n. Order of log n. तो यहाँ पर n की वैल्यू है n into 2 power n. मतलब टाइम लगेगा log of n into 2 power n. Using property of log अगर आप expand करोगे, this is nothing but log n plus log of 2 power n. So this become log n plus n. So if you take the order of it, will be order of n, theta of n. So therefore the answer is C. Many people are going wrong. Many people are going wrong. Correct? Many people, maybe Satish Kumar, you have applied this property wrong. Log AB is log A plus log B. Satish Kumar, log A plus log B. So when you expand, it become like this. So the correct answer is C for this. Come on, boys and girls. चलिए इसका आंसर बोलिएगा, इसका आंसर बोलिएगा प्लीज. नेक्स्ट क्वेश्चन. कम ऑन बॉयज एंड गर्ल, थोड़ा जल्दी करेंगे, फिर हम ऑपरेटिंग सिस्टम का क्वेश्चन भी सॉल्व करना है. जल्दी कीजिएगा प्लीज. Come on, what is the answer for this? Which one of the following is the tightest, closest upper bound that represent the time complexity of inserting an element into a binary search tree? देखिएगा, in comparison to previous question, यहां पर सिर्फ binary search tree दिया गया है, बैलेंस बाइनरी सर्च ट्री नहीं है. बैलेंस सिर्फ बाइनरी सर्च ट्री. मतलब वर्स्ट केस में हमें देखना है. वर्स्ट केस विल हैपन व्हेन द बाइनरी सर्च ट्री इज अ स्क्यूड बाइनरी ट्री. स्क्यूड बाइनरी सर्च ट्री, राइट स्क्यूड ट्री या फिर लेफ्ट स्क्यूड ट्री, या फिर लेफ्ट स्क्यूड ट्री. तो टाइम कॉम्प्लेक्सिटी इसका राइट स्क्यूड और लेफ्ट स्क्यूड के लिए ऑर्डर ऑफ एन होगा. ऑर्डर ऑफ एन होगा फॉर इंसर्टिंग एन एलिमेंट और डिलीटिंग एन एलिमेंट इन ए बाइनरी सर्च ट्री. इन द वर्स्ट केस विल बी ऑर्डर ऑफ एन. सो द आंसर फॉर दिस इज दिस. हाँ बच्चों, अगर यहां पर इनटू ए बैलेंस्ड अगर वर्ड आता, यहां पर अगर बैलेंस्ड वर्ड आता, जब आपका आंसर होता लॉग इन. जब अगर वर्ड बैलेंस आएगा पिछले क्वेश्चन की तरह, तो यहां पर हम बोलेंगे ऑर्डर ऑफ लॉग इन. रिमेंबर दिस. अगर सिर्फ बाइनरी सर्च ट्री पूछा जाएगा तो हम वर्स्ट केस में लेंगे स्क्यूड ट्री. अगर बैलेंस बाइनरी सर्च ट्री पूछा जाएगा तो आंसर बनेगा सिर्फ लॉग इन. सो बी केयरफुल विद दैट सिमेंटिक्स. चलिए इसका आंसर जल्दी बता दीजिएगा प्लीज. इसका आंसर बता दीजिएगा. द नंबर ऑफ एलिमेंट दैट कैन बी सॉर्टेड इन ऑर्डर ऑफ लॉग एन टाइम यूजिंग हीप सॉर्ट. नंबर ऑफ एलिमेंट दैट कैन बी सॉर्टेड इन ऑर्डर ऑफ लॉग एन टाइम यूजिंग हीप सॉर्ट. व्हाट इज द आंसर फॉर दिस? यहां पर क्वेश्चन पूछा जा रहा है कि कितने एलिमेंट्स आप सॉर्ट कर सकते हो. समझने की चीज है यहां पर, कितने एलिमेंट्स आप सॉर्ट कर सकते हो यूजिंग हीप सॉर्ट, इन हाउ मच टाइम? लॉग एन टाइम. इन हाउ मच टाइम? लॉग एन टाइम. देखिएगा प्लीज, यहां पर समझने की कोशिश कीजिएगा. मेनी पीपल गो रॉन्ग विद दिस. व्हाट इज द टाइम कॉम्प्लेक्सिटी? व्हाट इज द टाइम कॉम्प्लेक्सिटी ऑफ हीप सॉर्ट? टाइम कॉम्प्लेक्सिटी ऑफ हीप सॉर्ट इज n into log n for how many elements? For n elements. अगर मेरे पास n elements हो, the time complexity of heap sort will become n log n. ठीक है ना? Right? It can be done in order of n log n. लेकिन अब पूछा यह जा रहा है, अगर मुझे टाइम सिर्फ log n चाहिए, अगर मुझे सिर्फ टाइम log n चाहिए, तो इसका स्ट्रेट फॉरवर्ड मतलब यह हुआ कि नंबर ऑफ एलिमेंट शुड बी लेस देन n. ये बात समझने की है. अगर मुझे सिर्फ टाइम log n चाहिए, नंबर ऑफ एलिमेंट शुड बी लेस देन n. लेस देन n. अगर मेरे पास n स्क्वायर एलिमेंट्स होंगे, n स्क्वायर, तो कितना टाइम लगेगा? n स्क्वायर इंटू log n स्क्वायर, विच इज log n. n स्क्वायर इंटू log n होगा. अगर मेरे पास सिर्फ log n एलिमेंट्स होंगे तो टाइम कितना बनेगा? log n इंटू log n, log n इंटू log n. तो अगर मेरे पास सिर्फ थीटा ऑफ वन कांस्टेंट नंबर, लिसन टू मी, यहां पर कंफ्यूजन है. अगर मेरे पास कांस्टेंट नंबर ऑफ एलिमेंट्स होंगे तो मेरा टाइम कॉम्प्लेक्सिटी भी कांस्टेंट होगी, ऑर्डर ऑफ वन. प्लीज फॉलो दिस पॉइंट. मेनी पीपल गो रॉन्ग विद दिस क्वेश्चन. इफ माय नंबर ऑफ एलिमेंट्स आर ऑर्डर ऑफ वन, माय टाइम कॉम्प्लेक्सिटी इज आल्सो ऑर्डर ऑफ वन, क्योंकि यहां पर कांस्टेंट सब्स्टिट्यूट करना पड़ेगा. कांस्टेंट इंटू कांस्टेंट इज कांस्टेंट. सेकंड ऑप्शन में देखिएगा, इफ माय नंबर ऑफ एलिमेंट्स आर रूट log n, मेरा टाइम कॉम्प्लेक्सिटी कितना होगा? मेरा टाइम कॉम्प्लेक्सिटी होगा रूट log n into log of root log n, which is again log of log n by 2. ये टाइम बनेगा. This function root log n into log n is greater than log n, is greater than log n. But I want the time to be only log n. तो टाइम रूट log n बन रहा है, टाइम रूट log n बन रहा है, it is greater than log n. तो मतलब my number of elements cannot be this also. My number of elements cannot be this. Because if number of elements are constant, time is constant. If number of elements are root log n, time is root log n into log n, which is greater than log n. Heavy mathematics with regard to functions. आपको फंक्शंस की अंडरस्टैंडिंग क्लियर हो तो ये क्वेश्चन सॉल्व कर सकते हो, वरना नहीं। उसी तरह बच्चों मैं ये ऑप्शन पे आ रहा हूं, सुनिएगा, लॉग एन। अगर मेरे नंबर ऑफ एलिमेंट्स लॉग एन है तो टाइम कॉम्प्लेक्सिटी कितना होगी? बाई फंक्शन इट विल बिकम लॉग एन इनटू लॉग एन। देखिएगा, मुझे टाइम चाहिए लॉग एन और यहां पर टाइम आ रहा है लॉग एन इंटू लॉग एन। लॉग एन इंटू लॉग एन इज स्टिल ग्रेटर देन लॉग एन, स्टिल ग्रेटर देन log n। मतलब मेरे नंबर ऑफ एलिमेंट्स कैन नॉट बी इवन log n also, it has to be less than log n, it has to be less than log n। Are you getting my point? It has to be less than log n। तो एक ही फंक्शन बचा less than log n, ये है log n by log n, ये है log n by log n। ये फंक्शंस की क्लासिफिकेशन हम एक बोलते हैं, इट इज कॉल्ड ईसोटेरिक फंक्शन। मैथमेटिक्स में ये फंक्शन का नेम है ईसोटेरिक फंक्शन, मतलब क्रिप्टिक फंक्शन, मतलब एक छुपा हुआ फंक्शन, एक कॉम्प्लेक्स फंक्शन आप बोल सकते हो, ईसोटेरिक फंक्शन। log n by log n। तो इफ माई नंबर ऑफ एलिमेंट्स इन हीप सॉर्ट इज log n by log n, देन टाइम कॉम्प्लेक्सिटी शुड कम टू log n। वी हैव टू प्रूव इट। कैसे प्रूव करेंगे? यहां पे प्रूव करेंगे, देखिएगा। इफ नंबर ऑफ एलिमेंट्स आर, ऐसे लिखेंगे कैपिटल N, नंबर ऑफ एलिमेंट्स आर गिवन बाई log n by log n esoteric function, then what will be the time complexity? Time complexity will be n log n, right? So therefore log n by log n into log of this value, log n by log n, ये बनेगा, ठीक है। तो you have to simplify this, listen to me boys and girls, you have to simplify this function and prove that using property of log, you have to simplify this function and prove that this is equal to log n, is equal to log n, order of log n। कैसे प्रूफ करेंगे? प्रॉपर्टी ऑफ लॉग, सुनिएगा बच्चों। दिस इज टू मल्टी, दिस log a by b, log a by b is log a minus log b। चलिए फर्स्ट लेवल ऑफ एक्सपेंशन अगर आप करोगे, दिस टर्म एज इट इज log n by log n, log n into log a by log b, log a by b, log a minus log b। So therefore first term can be written as log n minus log n, ऐसे बनेगा। ओपन कीजिए एक्सपैंड कर कर, log n into this, when I multiply this and this will cancel, look at this and this will cancel in the first term। So first term will be log n minus second term will be log n by log n into log n। By taking suitable values of n, you can prove that the second term is definitely less than log n. You can prove that the second term is definitely less than log n। So log n minus a term less than log n, if you take the order of this is nothing but order of log n. Hence proved. That means when my number of elements are log n by log n, the time complexity of heap sort has come to order of log n. That is the beauty of this question. When the number of elements are log n by log n, the time complexity of heap sort is proved to be order of log n. And that is what is asked in the question. How many number of elements that can be sorted in log n time? So number of elements has to be log n by log n. Reverse method. You cannot make a derivation for this. You have to work out by choices like this. You have to work out by choices in this fashion. ठीक है ना? चलिए आगे बढ़ेंगे बच्चों। बहुत सिंपल क्वेश्चन है, आंसर बताइएगा प्लीज। रिपीटेड क्वेश्चन है, काफी बार रिपीट हुआ है, इसे आपको याद रखना है। सिलेक्शन सॉर्ट की प्रॉपर्टी है, नंबर ऑफ व्हाट इज द नंबर ऑफ सॉर्ट्स दैट कैन बी डन, नंबर ऑफ सॉर्ट्स दैट कैन बी डन इन सिलेक्शन सॉर्ट in the worst case or all cases, order of n। So therefore the correct answer is B. The correct answer is B। चलिए बच्चों नेक्स्ट क्वेश्चन पे जाएंगे। चलिए इसका आंसर बताइएगा प्लीज। ये बेसिस पर एक और क्वेश्चन मैं डिस्कस करूंगा विच वाज आस्क्ड इन गेट डीए पेपर, फर्स्ट पेपर ऑफ डेटा साइंस एंड मशीन लर्निंग का क्वेश्चन था, और विथ रिगार्ड टू क्विक सॉर्ट वो भी क्वेश्चन डिस्कस करेंगे हम। इसका आंसर बता दीजिएगा प्लीज। यू हैव एन एरे ऑफ n एलिमेंट्स, you implement quick sort by always choosing the central element of the array as the pivot, then what is the tightest upper bound for the worst case performance? Time complexity, worst case time पूछ रहा है। What is the worst case time in quick sort if central element is taken as pivot? तो देखिएगा बच्चों, यहां पर मैं आपको बताना है कि इफ दिस इज माई अरे ए, सम एलिमेंट्स 1 2 3 4 5 6 7 and so on. So some values are there. Let us say some values x, y, z, p, q, r, a, t, something like this. Any element can be selected as pivot. In the traditional implementation of quicksort, first element is selected as pivot, right? The person who implemented quicksort, Hoare, has selected the first element as pivot. Any element can be selected. You can select middle element, you can select 1/3 element, 1/4 element, n smallest element, any element. As per the question, he say that middle element, let us say this is our middle element, this is selected as pivot. जब आप ये एलिमेंट को पाइवोट सेलेक्ट करोगे तो पार्टीशनिंग कैसे करोगे? पार्टीशनिंग यहां से नहीं करोगे. द प्रोसीजर इज, आई सेड यू विल हैव टू स्वैप दिस विद फर्स्ट एलिमेंट. ये दोनों को स्वैप करना होगा. तो यू ब्रिंग q हियर एंड ट्राई टू फाइंड, यू ब्रिंग q हियर एंड x हियर, एंड देन यू ट्राई टू फाइंड व्हाट इज द करेक्ट प्लेस ऑफ q by partitioning approach, 2-pointer approach or common 1-pointer approach. Either way, you try to find what is the correct place of q. ये दोनों को स्वैप करना पड़ेगा, राइट? स्वैप करना पड़ेगा. उसके बाद पार्टीशनिंग प्रोसीजर अप्लाई करके देन यू विल हैव टू फाइंड व्हाट इज द करेक्ट प्लेस ऑफ q. सो इन द वर्स्ट केस, जब क्योंकि यहां पे वर्स्ट केस परफॉर्मेंस बोल रहा है, वर्स्ट केस में ऐसा हो सकता है कि दिस एलिमेंट मे गेट पाइवोटेड इन द लास्ट पोजीशन और मे गेट पाइवोटेड एट दिस प्लेस, क्रिएटिंग द वर्स्ट केस सिनेरियो. So in the worst case scenario, the pivot should get pivoted, partitioning element should get pivoted at the first plate or last place, leading to one partition having n-1 elements, leading to one partition having n-1 elements. So therefore आपका recurrence बनेगा T of n is equal to order of n time for partitioning plus the time complexity recursively to solve n-1 elements, because it get pivoted here or here, leading to n-1 elements. If you simplify this, this is order of n square. So therefore that answer for this is order of n square. So remember this point, pivot. एक क्वेश्चन आया था क्विकसॉर्ट का, मीडियन इज सेलेक्टेड एज पाइवोट. मीडियन इज डिफरेंट, सेंट्रल एलिमेंट इज डिफरेंट. मीडियन इज द मिडिल एलिमेंट ऑफ सॉर्टेड लिस्ट. यहां पर मिडिल एलिमेंट ऑफ सॉर्टेड लिस्ट नहीं कहा गया, यहां पर कहा गया सेंट्रल एलिमेंट, मतलब मिडिल एलिमेंट ऑफ गिवन लिस्ट, मिडिल एलिमेंट ऑफ गिवन लिस्ट. ये दोनों चीजों में जनरली स्टूडेंट्स विल गेट कंफ्यूज. आई वांट यू टू ब्रिंग टू दैट नोटिस. ठीक है ना? तो चलिए, दिस इज ऑल्सो सिंपल क्वेश्चन, यू कैन इसका आंसर बता दीजिएगा प्लीज. दिस इज इंटरेस्टिंग क्वेश्चन, दिस इज इंटरेस्टिंग क्वेश्चन. प्लीज वर्क आउट दिस. प्लीज वर्क आउट दिस प्रॉब्लम. ओरली मैं आंसर बताऊंगा इसका. What is the answer for this, boys and girls? An unordered list, unsorted. Unordered means unsorted list contains n distinct elements. The number of comparisons to find an element in this list that is neither maximum nor minimum. एक लिस्ट है जिसमें n एलिमेंट्स है, राइट? अनऑर्डर्ड है, डिस्टिंक्ट एलिमेंट्स है. उसका हमें नाइदर मैक्सिमम नॉर मिनिमम, मे बी सेकेंड मैक्सिमम, सेकेंड मिनिमम, जो भी बोलो आप उस डिटरमिन करना है. तो हम कैसे कर सकते हैं? सम पीपुल विल से सर सॉर्ट कर लीजिएगा, एनलॉग एन टाइम होगा, देन अनलॉग एन टाइम, और मे बी बाइनरी सर्च अप्लाई कर लीजिएगा. दिस इज ऑल नथिंग. यू हैव टू अप्लाई कॉमन सेंस. द कॉमन सेंस हियर से दैट you select any 3 elements. Boys and girls, please listen to me. Select any 3 elements, and among the 3 elements with constant number of comparisons, you find the second maximum or you find the second minimum. That can be done in order of 1 time. That can be done in order of 1 time. So therefore the answer for this will become order of 1. How? Select 3 elements, any 3 elements of the list. Find the second maximum. I'm not saying maximum, second maximum, or maybe second minimum. In just 2 comparisons से आप कर सकते हो. So therefore the answer for this is theta of 1. Theta of 1. Very good. हाँ, इसका आंसर बता दीजिएगा प्लीज. Tell me the answer for this question. Which one of the following is the recurrence equation for the worst case time complexity of the quicksort algorithm for sorting n greater than or equal to two numbers in the recurrence? Worst case अभी हमने derive किया था t of n minus 1 plus t of 1 plus cn. So therefore the correct answer for this is B. The correct answer for this is B. अभी हमने derive किया worst case scenario, वही है question. Answer is B. Not 2tn minus 1. अगर 2tn minus 1 बोलोगे तो गलत होगा उत्कर्ष. 2t, if you say 2tn minus 1, it is wrong. It is B. B is correct. चलिए ठीक है, ये भी क्वेश्चन अभी हम थोड़ी देर पहले देखे थे. इंसर्शन एंड डिलीशन का टाइम कॉम्प्लेक्सिटी लगेगा ऑर्डर ऑफ n. चलिए ये दिस इज ऑल्सो सिंपल क्वेश्चन. आई एम वेरी श्योर यू कैन डू दिस. ऑल्सो वेरी डायरेक्ट क्वेश्चन, फिर भी वर्कआउट कर लेंगे. कम ऑन डू दिस, देखेंगे वेदर यू रिमेंबर और नॉट. come on work out this fast. The worst case running times of insertion sort, यहां पे लिखेंगे हम n square. Merge sort is always n log n and quick sort is always n square. So देखिएगा n square n log n and n square n log n and n square. So therefore the option is D. Option is D. Correct? Option is D. Eon Debian, you are wrong. So option is D. चलिए नेक्स्ट क्वेश्चन पे आएंगे. चलिए इसका आंसर बताइएगा प्लीज. टेल मी द आंसर फॉर दिस. टेल मी द आंसर फॉर दिस. He says that the input is already in order. If the input is already in ascending order, then which of the following are true? Which of the following are true? If the input is already in ascending order, which of the following are true? अगर input order में हो तो quicksort will take n square time, perfectly correct. Bubble sort, no, it may not take n square time. It can run in best case. Merge sort will never take order of n time. Insertion sort may run in order of n time. So therefore 1 and 4 are correct. 1 and 4. So therefore option D is correct. Option D is correct. चलिए next. This is a simple one, you can do it. हाँ, इसका आंसर बताइएगा प्लीज. 2021 लेटेस्ट पेपर का है, गेट 2021, बेस्ड ऑन सॉर्टिंग. Consider the following array. Which algorithm out of the following option uses the least number of comparisons among the array element to sort the above array in ascending order? These type of questions are important, boys and girls. These type of questions are important. प्रमित प्रमाणिक, बेटे आप गौर कीजिएगा, मर्ज सॉर्ट की टाइम कॉम्प्लेक्सिटी कभी भी n स्क्वायर नहीं होगी. मर्ज सॉर्ट की टाइम कॉम्प्लेक्सिटी हमेशा n log n रहेगी. रिमेंबर दैट, दैट्स अ वेरी सिंपल पॉइंट. सो स्ट्रेट अवे द आंसर फॉर दिस इज इंसर्शन सॉर्ट. अगर बबल सॉर्ट होता तो हम बबल सॉर्ट भी लेते थे आंसर, लेकिन इंसर्शन सॉर्ट दिया गया है. विल गो फॉर इंसर्शन सॉर्ट. मेनी पीपल टोल्ड द करेक्ट आंसर, सो दैट इज एब्सोल्युटली करेक्ट. कम ऑन, इसका ये भी स्टार क्वेश्चन है. लेट मी मार्क दिस स्टार क्वेश्चन. दिस स्टार क्वेश्चन. कम ऑन बॉयज एंड गर्ल्स, टेल मी द आंसर फॉर दिस. इज एग्जैक्टली बेस्ड ऑन द टॉपिक विच आई डिस्कस्ड इन डिवाइड एंड कॉन्कर. मैक्समिन का जो प्रॉब्लम मैं डिस्कस करता हूं उससे रिलेटेड डायरेक्ट प्रॉब्लम है ये. Tell me the answer for this question, boys and girls. Let P be an array containing n integers. Let T be the lowest upper bound on the number of comparisons of the array elements required to find the minimum and maximum values in an arbitrary array of n elements. तो divide and conquer maximin का equation अगर आप याद करोगे, right? So the time complexity using divide and conquer, जो equation हम derive किए थे number of comparisons के लिए, if you remember it was 3n by 2 minus 2 using divide and conquer method, right? And non-divide and conquer, because he's not mentioning here, non-divide and conquer method में it was 2 into n minus 1, worst case में 2 into n minus 1. So therefore from this I can basically conclude that the time, the t number of comparisons, t is the number of comparisons, will be definitely greater than n and less than or equal to 3n by 2 minus 3n by 2. So therefore based on this the answer has to be A. Based on this, the answer has to be A. Based on divide and conquer method. ठीक है. Next questions लेंगे greedy method पर. पहले सबसे पहले इसका आंसर बताइएगा. Many people go wrong with this, so that's why I want to start with this question first. Many people go wrong with this. Many people go wrong with this, so I want you to start with this question. Let P, Q, R, S, T are sorted sequences having lengths 20, 40, 30, 35, 50 respectively. They are to be merged into a single sequence by merging together two sequences at a time, two-way merge. So this question is purely based on my problem which I discussed, optimal two-way merge pattern. Optimal merge pattern. जो प्रॉब्लम हम डिस्कस करते हैं ऑप्टिमल मर्ज पैटर्न, उसके बेसिस पर है ये क्वेश्चन, डायरेक्ट क्वेश्चन. Merging together two sequences at a time, the number of comparisons that will be needed in the worst case by the optimal merge algorithm for doing this. So let me see who will give the correct answer. Come on, boys and girls, tell me the answer for this. Tell me the answer for this. Tell me the answer for this. Number of comparisons he is asking. 358. Many people are saying 358. देखिएगा. So first I have to arrange them in increasing order. Take the two smallest. So I will take the two smallest. 20 and 24. ठीक है? These two will be merged to get one file, two-way merging, which will have 44. And number of comparisons required will be less than 1. 43 maximum. 43. Then I have now 44, 30 and 35. So I am going to merge 30 and 35. I am going to merge 30 and 35. 30 and 35 because 44 is greater than that. So these two will be merged. 65. Number of comparisons will be 64. Then I have 44, 65 and 50. Remaining are consumed. I have 50. So 44 and 50 will be merged. This will give you 94. This will give you 94. Number of record movements, 94, right? And then finally 65 and 94 by bringing 65 here. 30 and 35. So we remove this. Then finally these two are to be merged. So 90 plus 60 plus 9, this is 9 plus 159. What is the total number of comparisons? The number of comparisons that will be needed in the worst case by the optimal algorithm for doing this. What is the answer? If you say 194, 159, it is wrong. It is wrong. This is only for the last step. Total number of comparisons. How many steps of merging I have? 1, 2, 3, 4. So in all these I have to write. In all these I have to write. Here how many comparisons? 43. Here how many comparisons? 93. Here how many comparisons? Because if you remember, if I have list L1 with N1 elements, list L2 with N2 elements, in the worst case, how many comparisons are needed to merge them? N1 plus N2 minus 1. I am using that formula. So here I have 64. Here I have 158. So total comparisons you have to add up these and tell. That is the answer. 158 plus 93 plus 43 plus 64. 7, 8, 9, 10, 8 and carry 1, 5, 6. 15, 15 plus 4, 19, 19 plus 6, 25. I think 358. 358. 358 is correct. Abhay Singh is saying 362. Is it 362 or 358? Whatever it is, you have to add up this and that is your answer. That is your answer. I hope you understood. Is it clear, boys and girls? Please tell me in the chat box. Am I clear? Is this problem solving clear? Okay, got it. Very good. Chaliye, next. Star question. Again a star question, boys and girls. This is again a star question. Please work out and tell. I am giving the opportunity first to work out. Come on, come on, come on. It's a star question. People make mistake in this. Consider the string so and so. Each letter in the string must be assigned a binary code satisfying the following. For any two letters, the code assigned to one letter must not be a prefix. Prefix code का मतलब है Huffman code. Huffman code is a prefix code. मतलब no code will satisfy, no two codes always will satisfy prefix property. मतलब no code will contain the part of the other code. That is called prefix property, right? So prefix code मतलब Huffman code. For any two letters of the same frequency, अगर दो letters की frequency same हो, the letter which occurs earlier in the dictionary, जैसा A occurs before B, B occurs before C. So earlier in the dictionary order is assigned a code whose length is at most the length of the code assigned to the other letter. मतलब जो character पहले occur हो रहा है dictionary में, उसका length कम होना चाहिए than the other. That is the meaning of second condition. तो हमें determine करना है among the set of all binary code assignments which satisfy the above two properties, what is the minimum length of the encoded string. ये जो string है, जो encode करेंगे आप, जो codes आएंगे उससे encode करेंगे तो उसकी length कितनी होगी. क्या करेंगे हम? सीधा सीधा हफमन कोडिंग अप्लाई करेंगे. लेकिन हफमन कोडिंग अप्लाई करते हुए यू हैव टू बी केयरफुल. तो सबसे पहले मैं नेक्स्ट पेज पे सॉल्व करूंगा क्वेश्चन. हम स्ट्रिंग ले लेंगे a फॉलोड बाय 2b 2c 2d. सो माय स्ट्रिंग इज a फॉलोड बाय 2b 2c 2d 3e. दैट मींस इफ आई राइट द फ्रीक्वेंसीज, द फ्रीक्वेंसी ऑफ a इज 1, b इज 2, c इज 2, d इज 2, e इज 3. तो हफमन कोडिंग कैसे करेंगे? यहां पर कई बच्चों को डाउट होता है, सो प्लीज आई वुड रिक्वेस्ट यू टू हैव अ लुक ऑन बोर्ड. तो सबसे पहले जो स्मॉलेस्ट है ए एंड बी, राइट. तो देखेगा ए की फ्रीक्वेंसी 1 है. अब ये देखेगा यहां पर बी और सी और डी की फ्रीक्वेंसी सेम है. बी सी डी की फ्रीक्वेंसी सेम है. तो अब मैं यहां पर पूछना चाहूंगा, वेरी इंटरेस्टिंग क्वेश्चन, यहां पर इंटरेस्टिंग क्वेश्चन है. यहां पर पूछना चाहूंगा ए के साथ यू कैन मर्ज आइदर विद बी और विद सी और विद डी. तो हम किससे मर्ज करना है देखेंगे कौन आंसर करेगा. दिस इज टू बी डन बाय अप्लाइंग दिस प्रॉपर्टी. सेकंड जो पॉइंट है, ये पॉइंट अप्लाई कर यहां पे हमें कहना है कि along with a which character we have to merge, b or c or d. Tell me, that's the point. B or C or D. We have to merge B or C or D. That's the most important question. We have to merge along with A, D. क्योंकि ये सबसे ज्यादा डेप्थ में जाएगा, ट्री में सबसे ज्यादा डेप्थ में जाएगा. तो along with A वो कैरेक्टर डेप्थ में होना चाहिए जो डिक्शनरी में आखिरी में आएगा. among B C D आखिरी में कौन आएगा? डिक्शनरी में D आएगा. आखिरी में D आएगा बच्चों. ये बहुत ज्यादा इंपॉर्टेंट पॉइंट है, कई बच्चे गलत दे रहे हैं आंसर. So along with A, you will have to merge with D, with frequency 2. Lexico order maintain करना है. D will go into more depth. तो ये दोनों को आप कंबाइन करोगे 3. तो अब मेरे पास देखिएगा ये कंज्यूम हो गया, D कंज्यूम हो गया. I have B and C with 2, 2 and this. तो नेक्स्ट लेवल पे कौन देखेगा? इसकी फ्रीक्वेंसी 3 है, ये दोनों की फ्रीक्वेंसी B and C की फ्रीक्वेंसी 2 and 2 है. तो वी आर गोइंग टू मर्ज B and C together. With frequency 2 to get 4. ठीक है ना? I hope you are getting my point. This is having lowest frequency, so that will go into more depth, right? So therefore D should come first. D should be merged, not B and C. देखिएगा इसकी frequency higher है. It will come to the top levels in the tree, in the optimal merge tree, right? अब देखिएगा now. So this is consumed, and this consume. What I have is E with 3 and 3. So therefore I can take up 3, E, 3. This is to be merged with these two to get value 6. Now finally I will have to merge 6 and 4. So 4 will come here with values B and C. B and C. This is C. And this value is 2 and 2. Okay. So I will remove this. Check. I'm doing for the first merge. Last merge, sorry, not first, last merge, 10. This is my final tree. Now when you start numbering the nodes, numbering the edges, left is 0, right is 1, left is 0, right is 1, left is 0, right is 1, 0, 1. तो देखिएगा यहां पर जो B का कोड है 0, 0, C का कोड है 0, 1, it is having lesser length than D which is 1, 1, 1, than D which is 1, 1, 1. So D occurring last, occurring at the end in the dictionary, so therefore its code is having more length than B and C. So let us write the code, let us write the codes, let us write the codes. What is the code of A? The code of A is 110, 110, 3 bits. The code of B is 00, 2 bits. The code of C is 01, 2 bits. The code of D 111, 3 bits. The code of E 10, 2 bits. So देखिएगा, these are prefix codes. Now this 00, there will never be any other code which will have prefix 00. 01 कोई भी कोड में 01 नहीं रहेगा, 10 कोई भी कोड में 10 नहीं रहेगा as a prefix. So now if you try to encode the string, A needed how many bits? 3 bits. Plus B, there are 2 B's, so 2 into the length of B, 2, plus there are 2 C's, 2 into length is 2, plus there are 2 D's, so 2 into the size 3, E, there are 3 E's into size 2. So if you add up 3 plus 4 plus 4 plus 6 plus 6, 12 plus 8, 20, 23. Answer is 23. Answer is 23. So therefore the correct answer is A. This is the approach of solving this question. चलिए आगे बढ़ेंगे. ये भी similar question है. As a homework you can try this. A question on spanning tree. Please tell me the answer for this problem. Let me see. Please tell me the answer for this question. This is based on spanning tree. First read the question. An undirected graph G is equal to V comma I contains n nodes named V1 to V2 to so on Vn. Two nodes Vi and Vj are connected if and only if that condition is true. The difference of the indices of the vertices should be less than or equal to 2. Each edge Vi and Vj is assigned a weight of I plus j. A sample graph with n equal to 4 is given. This is my graph V1, V2, V3, V4. V1, this is V2, this is V3, this is V4. This is V3 and V4. This is my graph. This is my graph. So please have a look. An undirected graph G is equal to V comma I contains n nodes named V1 to Vn. Two nodes Vi and Vj are connected if and only if that condition is satisfied. V1 to V4 difference will be how much? Difference will be 3. So it is greater than 2. So that's why there is no edge between V1 and V4. There is no edge between V1 and V4. So question is, what will be the cost of minimum spanning tree of such a graph with n nodes? What will be the cost of this spanning tree? अगर ये ग्राफ की आप स्पैनिंग ट्री का देखेंगे कॉस्ट, this will come out to be 3 plus 4 plus 5 cannot be included, 6. So for n is equal to 4, this is the cost of spanning tree. If you draw a graph with 3 vertices, it will be a complete graph. This is vertex 1, vertex 2, vertex 3. It will be a complete graph. The weight of this is 4, the weight of this is 3, the weight of this is 5. The weight of this spanning tree is 3 plus 4. ठीक है, 3 plus 4. तो ये spanning tree with n equal to 3 vertices, the weight of the spanning tree is 3 plus 4. n equal to 4, the weight of the spanning tree will be 3 plus 4 plus 6. अगर आप if you draw the graph for n equal to 5, the weight of spanning tree will be 3 plus 4 plus 5 plus 6 plus 3 plus 4 plus 6 plus 8. ये बनेगा weight. मतलब आप इसे सिंप्लीफाई कैसे कर सकते हो? I can write this as 3 plus 2 into 2. I can write this as 3 plus 2 into 2 plus 3. I can write this as 3 plus 2 into 2 plus 3 plus 4. So in general, for a given value of n, the weight of the spanning tree will be 3 plus 2 into 2 plus 3 plus 4 plus so on plus n minus 1. ये बनेगा आंसर. This will become the answer. So if you simplify further, it will become 3 plus 2 into, this is nothing but n into n minus 1 divided by 2 minus 1. So if you simplify this, the final answer will come as n square minus n plus 1. If you simplify this, n square minus n plus 1, The correct option is B. Check that again. If n equal to 3, this will be the cost of spanning tree. If n is equal to 4, this will be the cost of spanning tree. If n equal to 5, this will be the cost of spanning tree. So by and large, in general, for a given value of n, the cost of spanning tree will be given by this. So if you simplify this, the answer becomes n square minus n plus 1. So therefore, the correct answer is B. Questions like this are important, right? So we'll take up, this is a simple one, you can do it. Tell me the answer for this. Come on, boys and girls, tell me the answer for this. Let me just tell you that for solving this problem, you will have to apply the method of Dijkstra, not Prim's or Kruskal's, Dijkstra's method of minimum cost spanning tree. Generally, people are aware of Prim's method and Kruskal's method, but let me tell you, in my classes, I also talk about Dijkstra's method of spanning tree. Dijkstra's method of spanning tree. Matrix multiplication problem will come in dynamic programming. Dijkstra's method of minimum cost spanning tree, which say that you are supposed to ignore that edge among this in the cycle which is of highest weight. Exclude the edge with the highest weight. Yes, Abhay Singh is correct. So now the graph shown below has 8 edges with distinct integers. So here it is saying distinct. No two edges will have same cost value. So this is the spanning tree. The edges which are marked 15, 2, 9, 6 and 4 are marked. This is the spanning tree. Spanning tree will have 5 edges, 1, 2, 3, 4, 5. So he is asking the minimum possible sum weights of all 8 edges. मतलब हमें ये minimum value find out करना है, ये edge की minimum value find out करना है, ये edge की minimum value find out करना है. We need to find the minimum value of this edge. तो ये जो cycle बन रही है, तो ये अगर minimum होना है, तो this should have the maximum among these 3. So therefore this is 10. Highest value is 9. So therefore 10. ये cycle में अगर ये edge को आप ignore करोगे, it should be greater than 15. What is the least integer greater than 15? So that will be 16. In this cycle, if you are ignoring this, it should be greater than 6, but it should be of lesser value, least value, so therefore 7. So when you add up all these, I think the correct answer is 69. The correct answer is 69. Correct? Okay, fine. Let's proceed. Some logical questions, reasoning questions. इसका जल्दी answer बता दीजिएगा please. Reasoning questions are important, boys and girls. Reasoning questions are important. Distinct positive weight edges, if every edge weight is increased by the same value, हर edge की value same increase हुई है, then what is the question? Minimum spanning tree of G does not change. Shortest path between any pair of vertices does not change. Come on, tell me what is the correct answer for this question? What is the correct answer for this question? Boys and girls, please work out and let me know. Distinct weight edges. What is the answer for this? Minimum spanning tree of G does not change. That means when the edge cost is increased by same value, agar my edge cost, right now if you observe, the minimum cost spanning tree will be 1 and 2, edge width 1 and 2, 1 and 2. Shortest path between 2 and 3, it is 2, 1, 3. Please observe. Shortest path between 2 and 3 is 2, 1, 3. Because the total cost is 3 and this is 4. Now the question is, if I increase the edge cost, by some value, let us say 100, by value 100, by value 100. This become 102, 101, 104. So spanning tree will not change. Spanning tree will have the same structure. लेकिन shortest path change होगा ना? Correct? Shortest path change होगा नहीं? Earlier the shortest path was 213. Between 2 and 3 it was 213. Now the shortest path, which was earlier 213, changes to 23 directly, because this 104, this 203. This 203, this become 104. So shortest path got changed, meaning P will never change, this may change. So the correct answer is only P. So option A. Option A. So next question. This is again a slightly interesting question. People generally get confused with this. So I would like you to please read it and tell me the correct answer for this. Come on, read it. People generally go mistake with this. People generally make mistake with this. Come on, tell me the answer for this. Let G be a complete undirected graph on 4 vertices. 4 vertices है, having 6 edges, complete graph like this. ये complete graph हो गई आपके 4 vertices से, right? You can number it also as A, B, C, D. चलिए. Weights of the edges are 1, 2, 3, 4, 5 and 6. So any weight, any edge can have any weight. Any edge can have any weight. So this question is slightly interesting. The maximum possible weight, look at this. The maximum possible weight that a minimum weight spanning tree of G can have. What is the answer for this, boys and girls? What is the maximum possible weight that a minimum spanning tree can have? देखेंगे कौन बताएगा आंसर. The maximum possible weight that a minimum spanning tree can have. Yes. See, my point is, wherever the cost with edge 1 is there, wherever the cost with edge 1 is there, like imagine 1 is here, it has to always be part of spanning tree. This always has to be part of spanning tree. Next, because the edge weights are unique, अब 2 जहां पर भी हो, maybe this edge or maybe this edge or maybe this or maybe this or maybe this. So among the remaining edges, wherever there is 2, that means second least cost edge, that also compulsory it has to be there. That also compulsory it has to be there. Imagine that, for example, this is 2. This is 2. Even if it is here, it can be. Even here, it is here, it can be. But here, let us say it is 2. अब हमें decide ये करना है, next least edge जो है, वो है 3. वो है 3. Can 3 be part of spanning tree always? That is my question. Can the edge 3, can the edge with weight 3 be always part of spanning tree? No, answer is no. Because 3 may be part or may not be part. अगर 3 यहाँ होता it will be part, यहाँ होता it will be part. अगर ये होगा तो then it will also be part. But suppose if the weight of the edge, this edge B to D is 3, then the edge 3 cannot be part of spanning tree because that is forming a cycle. That is forming a cycle. So if 3 cannot be part of spanning tree, then what can be the next highest weight edge? 4. So there is a possibility that I can decline 3. If I include 3, then it become part of spanning tree. तो मेरा spanning tree होगा 3 plus 2 plus 1. लेकिन अगर 3 part नहीं हो रहा है, 3 is not becoming part of it, then I have to compulsory include 4. So therefore the maximum possible weight of minimum spanning tree, very interesting question, minimum spanning tree will be 1 plus 2 plus 4, 7. 7 is the answer. Some people are saying 15. We are not constructing maximum weight spanning tree. Please understand, we are constructing minimum weight spanning tree. But what is the maximum possible weight of it? Maximum possible weight is 7. Hope you understand. Hope you understand the question. So this is a very interesting question. Questions like this are tricky and slightly involved. So you have to be extremely careful. Come on, quickly tell me the answer for this question. Quickly tell me the answer for this question, boys and girls. Quickly tell me the answer for this. What is the answer for this? Nikhil Parmar, you have not understood my point. Rewind the video and check again what did I say. Nikhil Kumar. Nikhil Parmar, you have not followed what I am saying. 3 part हो सकता है. अगर 3 होगा तो आपका weight of spanning tree कितना बनेगा? 3 plus 2 plus 1, 6 बनेगा. क्या वो मिनिमम है weight of spanning tree? नहीं, मिनिमम उससे बढ़ के भी हो सकता है. वो पॉइंट है अंडरस्टैंड करने का. majority of the students will get confused with the previous question. So my advice is please watch it again and try to understand. Chaliye, next question. Is an undirected simple graph in which edges are distinct and E is a particular edge of G. ठीक है. Which of the following statements about the minimum spanning trees of G are true? If E is the lightest edge of some cycle in G, then every minimum spanning tree of G includes E. If E is the heaviest edge of some cycle in G, then every minimum spanning tree of G excludes E. What is your response for this? Are both of them true? Ion Debian, please tell me the answer for this. Is both of them true, or only one is true, or two is true, or both are false? See, by Dijkstra's algorithm जो अभी हमने पढ़ा, ये property satisfy होती है. So therefore this compulsory has to be true. But this may not be true always. So therefore 2 only is correct. Correct option is B. Ion Debian, इसीलिए मैं आपका नाम लिया हूं. Ion Debian. 2 is the correct answer. Only 2 is correct. Only option B is correct. So boys and girls, I would like to bring your attention to the point that ऐसे जो reasoning questions है वो बहुत important है. So my request is please concentrate on such questions and improve upon it. ऐसे ही questions से MSQ questions बनेंगे. So, okay? Yes. तो ये भी बहुत सिंपल इसी तरह पे है, आप कर सकते हो. These are simple things. इसका जल्दी मुझे आंसर बता दीजिएगा एक करके. हम फिर डायनेमिक प्रोग्रामिंग पे जाएंगे क्योंकि टाइम कम है. वो ऑपरेटिंग सिस्टम का एक क्वेश्चन भी मुझे सॉल्व करना है. Serial killer. The answer for that is, you can watch my paid batch. I have taken an example to prove why first option is wrong. You can take it very simple. You can take it very simple why first option is wrong. Come on. This is very simple. So all point one edges have to be there. NCR का कॉन्सेप्ट है यहां पर. NCR combinatorics. So all point one will consider all point one edges. Point one, horizontal point one. Sorry, yeah, this 0.9. So we should ignore this. And point one here. And where is point one? Point one here. Point one here. Point one here. ठीक है. That's it. Fine. So here बच्चों, if you observe carefully, 1 2 3 4 5 6 7 8 9 edges, 9 vertices. I need 8 edges. तो कितने edges हमें मिल चुके हैं? 1 2 3 4 5 6 7 edges we have taken. I need only one more edge. तो वो कौन सा edge? क्या ये edge हो सकता है? नहीं, ये नहीं हो सकता है. This cannot be considered. Can it be this? No, this cannot be considered. Can it be this? हाँ sir. Can it be this? हाँ sir. Can it be this? So that means out of these three I have to take only one. So the answer becomes 3C1. Out of these three I have to select one. 3C1. So 3C1 is 3. The correct answer is 3. The correct answer is 3. Very simple question. चलिए, डायनामिक प्रोग्रामिंग का क्वेश्चन. दोज हु आर आस्किंग फॉर मैट्रिक्स मल्टीप्लिकेशन सॉल्व नहीं करूंगा, मेथड अप्लाई करके छोड़ूंगा और आंसर बता दूंगा. आपने करना है डायनामिक प्रोग्रामिंग. ठीक है. मैट्रिक्स, दिस इज मैट्रिक्स चेन प्रोडक्ट, MCP. मैट्रिक्स चेन प्रोडक्ट का प्रॉब्लम है डायनामिक प्रोग्रामिंग में. आई वुड रिक्वेस्ट यू बी वेरी क्लियर विद द वर्किंग ऑफ मैट्रिक्स चेन प्रोडक्ट, लॉन्गेस्ट कॉमन सबसीक्वेंस, सम ऑफ सबसेट्स एंड अदर प्रॉब्लम व्हिच वी डिस्कस इन द क्लास. लेकिन प्रिडोमिनेंटली ये इंपॉर्टेंट टॉपिक्स है. मैट्रिक्स चेन प्रोडक्ट एंड देन द लॉन्गेस्ट कॉमन सबसीक्वेंस एंड देन सम ऑफ सबसेट्स. इसके ऊपर न्यूमेरिकल क्वेश्चन आ सकते हैं. सो हाउ मेनी मैट्रिसेस आई हैव? 4 matrices I have. Their dimensions are given. How many scalar multiplications are needed? How many scalar multiplications are needed? यहां पर आपको ट्री बता के छोड़ूंगा तो आप वहां से कंटिन्यू कर सकते हो. So I have matrices named as M1, M2, M3, M4. So at the first level I will have 3 points of splits. So I can split like M1 about the first matrix. Then the other subproduct is M2, M3, M4. Or I can split these about splitting about 1, case splitting about 2, M1, M2, M3, M4. Or I can split about third matrix, M1, M2, M3 to be multiplied by M4. This is the thing. Correct? then for this I will have 2 points of splits. So I can multiply with M2 to be multiplied by M3, M4, or M2, M3 to be multiplied by M4. Like that, here I can have two possibilities. You will have to multiply with M1 with M2, M3, and here M1, M2 to be multiplied by M3. So if you work out this, lengthy questions, yes, but you have to work out, there is no other go. So ये tree से आप अगर workout करोगे, the answer for this I think will come out to be 19,000. 19,000. You can do that. It's a matter of only practice. It's a matter of only practice. चलिए और एक क्वेश्चन देखेंगे डायनामिक प्रोग्रामिंग का. प्लीज रीड दिस. क्वेश्चन लाइक दिस कैन आल्सो बी आस्क्ड. An algorithm to find the length of the longest monotonically increasing sequence, just like longest common subsequence, monotonically increasing sequence of number in an array. Let Li denote the length of the longest monotonically increasing subsequence starting at index I in the array. So will be given by this formula. ये formula से आप कर सकते हो. If a of I is less than a of I plus 1. अगर ये condition satisfy होगा तो मतलब it is increasing sequence. So just like longest common subsequence, it will be L1 plus L of I plus 1. You are going to the next number in the array, and like that you continue. So question is, which of the following statements are true? This problem can be solved using which design strategy? ऐसे questions आ सकते हैं, super duper important. आपको प्रॉब्लम का डिस्क्रिप्शन दिया जाएगा, प्रॉब्लम का सॉल्यूशन दिया जाएगा जिस तरीके से ये प्रॉब्लम दिया गया है, एंड देन ही विल आस्क व्हाट इज द एल्गोरिथम डिजाइन स्ट्रेटजी. देखिएगा, द एल्गोरिथम यूजेस डायनामिक प्रोग्रामिंग, द एल्गोरिथम यूजेस लीनियर कॉम्प्लेक्सिटी एंड यूजेस ब्रांच एंड बाउंड. गेट 2011 का क्वेश्चन है, ब्रांच एंड बाउंड. द एल्गोरिथम यूजेस नॉन लीनियर पॉलिनोमियल कॉम्प्लेक्सिटी एंड ब्रांच एंड बाउंड. द एल्गोरिथम यूजेस डिवाइड एंड कॉन्कर पैराडाइम. तो बच्चों ये क्वेश्चन पूछा जा रहा है विद द वर्ड ब्रांच एंड बाउंड. इसीलिए मेरे अपने कोर्स में, पेड कोर्स में, मैंने एक ब्रीफ इंट्रोडक्शन दिया था आपको रिगार्डिंग बैक ट्रैकिंग एंड ब्रांच एंड बाउंड टू टेक अप, टू ट्रीट दिस टाइप ऑफ क्वेश्चंस. तो दिस कैन बी सॉल्व वेरी इजीली यूजिंग डायनामिक प्रोग्रामिंग. इसका आंसर है ए. इसका आंसर है ए. दिस डायनामिक प्रोग्रामिंग. देखिएगा आप, सबस्ट्रक्चर प्रॉपर्टी है और ओवरलैपिंग सब प्रॉब्लम्स रहेंगे यहां पर, आप इजीली प्रूव कर सकते हो. सो देयरफॉर दिस कैन बी इजीली सॉल्व यूजिंग डायनामिक प्रोग्रामिंग, नॉट ब्रांच एंड बाउंड. लेकिन आपको पता होना चाहिए व्हाट इज बैक ट्रैकिंग एंड व्हाट इज ब्रांच एंड बाउंड. ठीक है, चलिए ये भी देखिएगा, ऐसे टाइप का क्वेश्चन. आई एम नॉट वर्किंग आउट दिस, आई एम जस्ट ट्राइंग टू इलस्ट्रेट what kind of problems can be asked using longest common subsequence. Direct data set may be given. This is a string A, string B. They are asking what is the common subsequence of them. What is the longest common subsequence of them? So therefore, he is saying length of the common subsequence not necessarily contiguous between A and B, and let Y be the number of such common subsequence, then X plus 10Y is how much. So you have to find the longest common subsequence, and you have to find how many subsequences are there. Either you can use tree method, or you can use that matrix method which we worked out, and then you can work out, you can get the answer, right? You can work out this. चलिए एक मैचिंग पेयर है, मैचिंग पेयर से बताइएगा प्लीज. तो ये मैचिंग पेयर डिस्कस करने का, देखिए गेट 2015 का है. इट इज नॉट अ पास्ट पेपर, बहुत पुराना पेपर का नहीं है, 2015 का है. तो यहां पर वही आपको मुझे कहना है, वही बात आपको दोहराना है, वही बात आपको कहना है कि देखिएगा यहां पर एक ऑप्शन दिया गया है बैक ट्रैकिंग. बैक ट्रैकिंग तो मतलब यह है कि आपको एक ब्रीफ ओरिएंटेशन होना चाहिए एटलीस्ट. व्हाट इज बैक ट्रैकिंग, व्हाट आर द प्रॉब्लम्स दैट आर सॉल्वेबल बाय बैक ट्रैकिंग, ये आपको पता होना चाहिए. अगर ये पता नहीं हो रहा है तो देन यू कैन वर्क आउट, कैन नॉट इट सच क्वेश्चन में बिकम डिफिकल्ट इफ नॉट इम्पॉसिबल, राइट. तो देखिएगा, प्रिम्स एल्गोरिथम, ग्रीडी मेथड, ठीक है, फ्लॉयड-वार्शल्स एल्गोरिथम, ऑल पेयर शॉर्टेस्ट पाथ, डायनामिक प्रोग्रामिंग, मर्ज सॉर्ट, डिवाइड एंड कॉन्कर. तो हैमिल्टोनियन सर्किट ये लगेगा बैक ट्रैकिंग. बैक ट्रैकिंग ये आपका आंसर है. ठीक है. सो दिस टाइप ऑफ क्वेश्चंस आर आल्सो इंपॉर्टेंट. विच स्ट्रैटेजी इज यूज्ड टू सॉल्व विच काइंड ऑफ प्रॉब्लम्स. सो सच क्वेश्चंस आर आल्सो इंपॉर्टेंट. दैट्स राइट. अगेन एक मैचिंग पेयर है, आप कर सकते हो अपने तौर से. देयर इज नो प्रॉब्लम, आई एम वेरी श्योर यू कैन डू इट. देखिएगा यहां पर फिर से रिपीट हो रहा है, बैक ट्रैकिंग सर्च ऑन ए ग्राफ. यहां पे लिखूंगा मैं, डाइकेस्ट्रास शॉर्टेस्ट पाथ, ग्रीडी मेथड, फ्लॉयड-वार्शल्स एल्गोरिथम, डायनामिक प्रोग्रामिंग, बाइनरी सर्च, डिवाइड एंड कॉन्कर, बैक ट्रैकिंग सर्च ऑन ग्राफ, डेप्थ फर्स्ट सर्च, ये है, ऐसे आप वर्कआउट करोगे। ब्रेड्थ फर्स्ट सर्च इज एन एडिशनल ऑप्शन। सो इट इज डेप्थ फर्स्ट सर्च। बैक ट्रैकिंग में डेप्थ फर्स्ट सर्च यूज होता है, मैंने डिस्कस किया था अपने लेक्चर्स में, डेप्थ फर्स्ट सर्च। ब्रांच एंड बाउंड में ब्रेड्थ फर्स्ट सर्च यूज होता है। बैक ट्रैकिंग यूजेस डेप्थ फर्स्ट सर्च एंड ब्रांच एंड बाउंड यूजेस ब्रेड्थ फर्स्ट सर्च। तो चलिए ये हो गया है क्वेश्चंस, ये भी डायरेक्ट क्वेश्चन है, यू कैन वर्कआउट दिस अगेन मैचिंग पेयर, सिंपल वन, सो आई एम जस्ट इग्नोरिंग फॉर यू। देखिएगा कुछ मिसलेनियस क्वेश्चंस हो सकते हैं, मिसलेनियस टॉपिक्स यहां पर लिस्ट आउट करूंगा, आप उसे प्रैक्टिस कीजिएगा। मिसलेनियस टॉपिक्स फॉर एग्जांपल लाइक ग्राफ्स, ग्राफ टेक्निक्स इंपॉर्टेंट है, प्लस एप्लीकेशंस ऑफ इट। पर्टिकुलरली जो एप्लीकेशंस इंपॉर्टेंट है वो है टोपोलॉजिकल सॉर्ट, अपार्ट फ्रॉम ट्रैवर्सल्स। टेक्निक्स का मतलब ट्रैवर्सल्स और एप्लीकेशंस का मतलब है लाइक टोपोलॉजिकल सॉर्ट, टोपो सॉर्ट इज इंपॉर्टेंट। गेट के डीए पेपर में टोपोलॉजिकल सॉर्ट के ऊपर क्वेश्चन आया था। प्लस यू कैन ऑल्सो प्रिपेयर क्वेश्चंस ऑन हीप्स एंड जनरल सॉर्टिंग में टेक्निक्स, जनरल सॉर्टिंग टेक्निक्स, ये सारे टॉपिक्स कर लीजिएगा। यहां पर कुछ सिंपल क्वेश्चन मैं आपके लिए एक्सरसाइज के लिए कर रहा हूं, अगर आपको डाउट है तो मेरे टेलीग्राम चैनल पर आप जाकर पूछ सकते हो, डीएम कर सकते हो, आई विल ट्राई टू वेरीफाई फ्यू क्वेश्चंस आई विल टेक एंड देन I will take up that last question of operating system because we are nearing to it. So it's a very simple question on heap, you can do that. I will take a couple of questions. इसका आंसर बता दीजिएगा प्लीज। टोपोलॉजिकल सॉर्ट के ऊपर जनरली क्वेश्चंस काफी आए हैं, इंक्लूडिंग ये डीए पेपर जो रिसेंटली एग्जाम हुआ सैटरडे, डीए पेपर में एक टोपोलॉजिकल सॉर्ट के ऊपर क्वेश्चन था, उसी तरीका का क्वेश्चन गेट 2014 से मैं यहां पर लेकर आया हूं। प्लीज टेल मी व्हाट इज आंसर फॉर दिस टोपोलॉजिकल सॉर्ट। What is the answer for this? Consider the directed graph given below. Which of the following is true? The graph does not have any topological. देखिएगा एक सोर्स वर्टेक्स है, यहां सोर्स वर्टेक्स है, तो टोपोलॉजिकल सॉर्ट पक्का है। बोथ पी क्यू आर एस, देखिएगा पी के बाद क्यू प्रोसेस नहीं कर सकते आप, दिस इज रॉन्ग। पी के बाद कंपलसरी एस या एस के बाद कंपलसरी पी, मींस द टोपोलॉजिकल सॉर्ट शुड स्टार्ट विथ आइदर एस और पी। एस के बाद पी आएगा, पी के बाद एस आएगा, राइट? Hope you got the point. So therefore the correct answer is C. The correct answer is C. चलिए ये भी बहुत सिंपल है, आप वर्कआउट कर सकते हो। हीप्स के ऊपर भी काफी सिंपल क्वेश्चन है, यू कैन डू इट। हाँ ये देखेगा, ये क्वेश्चन है फ्रॉम रीसेंट पेपर ऑफ गेट डीए जो एग्जाम हुआ डेटा एनालिटिक्स एंड मशीन लर्निंग के बेसिस पर, जो फर्स्ट टाइम एग्जाम हुआ, इसका क्वेश्चन है। आप इसका आंसर बता दीजिएगा प्लीज, बोलिएगा। कंसीडर सॉर्टिंग द फॉलोइंग अरे, हो सकता है थोड़ा बहुत स्टेटमेंट चेंजेस हो, जो मुझे मिला है क्वेश्चन स्टूडेंट से मैं वो यहां पर लेकर आया हूं, हो सकता है इसमें कुछ मिस्टेक्स हो सकता है स्टेटमेंट में मिस्टेक हो, लेकिन ये क्वेश्चन मुझे डीए के पेपर से दिया गया है, बताया गया है बाय स्टूडेंट्स, नॉट बाय आईआईटी। सो कंसीडर sorting the following array of integers in ascending order using an in place quick sort that uses last element, boys and girls, last element as pivot, मतलब 100। इंक्रीजिंग ऑर्डर में है अरे। क्वेश्चन इट सीम्स सम पीपल वर सेइंग नंबर ऑफ स्वैप्स वर आस्क्ड एंड सम पीपल वर सेइंग नंबर ऑफ कंपैरिजंस वर आस्क्ड, लेकिन मेजॉरिटी ने कहा स्वैप, इसलिए मैं यहां पर स्वैप लिखा हूं। एक्चुअल क्वेश्चन में आई डोंट नो हु, आई मीन गॉड ओनली नोज व्हाट वाज आस्क्ड, बट इफ नंबर ऑफ स्वैप्स आर आस्क्ड then what is the answer? So many people are saying option is 0. I think if you say number of swaps, then option will never be 0, because simple point is these are worst case input. ये worst case input है, worst case input से number of swap 0 कैसे होंगे? ये worst case scenario for quick sort, worst case scenario of quick sort time complexity is order of n square, तो भैया आपके number of swaps कैसे बनेंगे? number of swaps कैसे बनेंगे? 0। सिंपल पॉइंट है। और सेकंड पॉइंट आपको देखिएगा, आप जो पार्टीशनिंग करेंगे कैसे करेंगे? whether you go for 2-pointer method or whether you go for 1-pointer method of Karman, with either way the number of swaps will come out to be same. Some people say no, with this method it is less, that method is more. It is not. Both the methods will be same. तो पार्टीशनिंग कैसे करेंगे? अभी मैं अपने लेक्चर में भी आपको बताया था पार्टीशनिंग कैसे करेंगे आप. You are going to swap the pivot, whichever element you have selected as pivot is the first element. अब यहां पर हमने ये एलिमेंट को पाइवोट सेलेक्ट किया है. तो पार्टीशनिंग आप यहां से नहीं करोगे ना, आप एल्गोरिथम चेंज नहीं कर दोगे, एल्गोरिथम तो वही रहेगा, राइट? सो यू आर गोइंग टू स्वैप दीस टू, दैट इज द फर्स्ट स्वैप. तो आप 100 यहां पर लाओगे, 60 यहां पर लाओगे. जो मेरा अपना 2-pointer मेथड में जनरली फॉलो करता हूं, 2-pointer मेथड. सो इफ यू गो विद 2-pointer मेथड, आप क्या करोगे? आई की वैल्यू यहां पर स्टार्ट करोगे, जे की वैल्यू यहां पे लास्ट बट वन एलिमेंट इनफाइनाइट से स्टार्ट, लार्ज एलिमेंट से करोगे आप. दिस आई, दिस इज जे. You keep on incrementing I to find an element which is greater than pivot. You keep on decrementing the value of J to find the element which is less than pivot. तो क्या होगा जब आप I की value, because this is 100. You compare 70 with 100, 80 with 100, 90 with 100. They are all lesser. So it keeps on increasing, and eventually I will point here now. And you decrease J will point here. 60. Yes, it is less than 100. So you got the position of pivot. So that means then you are going to extend 160 again. 160. मतलब per iteration of partitioning you are requiring 2 swaps. Per iteration of partitioning you are requiring 2 swaps with 2-pointer method. तो कितने आप iterations करोगे इसके, कितने partitions करोगे आप? 4 बार करोगे. List with one element is sorted. So 4 into 2, actually the answer according to me should be 8 as per the given question by students. ऐसे 8 आएगा. अगर आप कॉर्मन के मेथड से करोगे, 1-pointer मेथड जो जनरली करते हैं, that also will generate the same thing. You can verify that, you can check that. ठीक है? So that is about the question. हाँ ठीक है, ये भी एक क्वेश्चन उसी का है. This you can work out. ये DA पेपर का क्वेश्चन है with regard to topological sort. That is also very interesting. You can work out 2 options are correct. This is also very simple question on sorting from DA paper. 2 answers होंगे इसके. One is in the selection sort I suppose, and the other is insertion sort I suppose. Bubble sort and insertion sort, or selection sort and bubble sort. 2 passes में sort होना चाहिए. अरे, so you can try with that and do it. That's a very simple question. Chaliye, before coming to this, in the remaining time, as I promised, I will take up that question, which is an operating system question. See on board. Let us work out that and close. Listen to this. Multi-level paging का question है, as I promised. मल्टी-लेवल क्वेश्चन का पेपर का क्वेश्चन, मल्टी-लेवल पेजिंग का क्वेश्चन है. सो लेट्स सी दिस. ए प्रोसेसर यूजेस 36-bit फिजिकल एड्रेस एंड 32-bit वर्चुअल एड्रेस. बॉयज एंड गर्ल्स, दोज आर इंटरेस्टेड इन सीइंग दिस मल्टी-लेवल पेजिंग क्वेश्चन, प्लीज फॉलो. Each page table entry is of size 4 bytes. A 3-level page table is used for virtual to physical address translation, where the virtual address is used as follows. तो इसका स्ट्रक्चर अगर आप यहाँ पे बनाओगे, virtual address size, let's draw it here. 3-level paging का फॉर्मेट बनेगा like this: P1, P2, P3, offset D. Bits 30 and 31, 2 bits are used for index into the first level page table. 2 bits, 30 and 31, 0 to 31, 30 and 31. Then 21 to 29, 9 bits, 21 to 29 are used to index into the second level page table. 9 bits are used here. And 12 to 20, again 12 to 20, if you see, this will also be 9 bits for the next level page table, third level page table. And this is the page offset D, page offset. Page offset will depend on what, boys and girls? Yes, this is an example of non-uniform page size. That's right, that's correct. So page size is given to be, page size, look at that, page frame size of 4 kilobytes. The page size is 4 KB. So this implies the offset D is 12 bits. So this is 12 bits. This is the format of my virtual address, right? So pages, the virtual address space is divided into pages of size 4 KB. The virtual address space is divided into pages of size 4 KB. And page table entry size at all levels is 4 bytes. Given. Entry size is 4 bytes. Look at this. Look at this. Are you getting my point? And directly here we don't have to see how many pages are there. Everything is given here. Everything is given here. So question asked is, we have to see the question carefully. The number of bits required for addressing the next level page table or page frame in the page table entry of the first, second and third level page tables are respectively dashed. यहाँ पर देखिएगा ये first level का है. So there are 2 entries means 2 bits mean there are 4 entries here, because 2 bits are used to index into these outer page table, outermost page table, right? Outermost page table. 2 bits are used means it will have 4 entries. Size of each entry is 4 bytes. So therefore इसका size बनेगा 4 into 4 bytes, 16 bytes. 16 bytes. What will this entry contain? Predominantly this is important. What does this entry contain? This entry contains the address of the page or chunk of the next level page table. That is, अब हम इसे first level बोलेंगे तो first level page table, then second level, then third level. So this will contain the address, this address in the page table entry. So he's asking what is the size of this address for this page table. Now for this page table या page chunk, how many bits are used to index into it? Number of bits used to index into it is 9 bits. 9 bits. So follow me, those Harsh Thakkar and other people, Ayush Modi, follow me carefully. Chandra Prakash, Shrishti, please follow this carefully. So 9 bits are used to, this is page of next level page table. Next level page table. 9 bits are used to index into it. 9 bits. So matlab, this will have how many entries? This will have how many entries? This will have 2 power 9 entries, 512 entries. This will have 2 power 9, 512 entries. Are you getting my point? 9 bits are used to index it. Matlab there are 512 entries. Size of entry is 4 bytes. तो मतलब ये पेज का साइज कितना बना? ये पेज का साइज कितना बना? ये पेज का साइज बना 512 into 2 bytes. 512 into 4 bytes. So that will become 2 power 2, 2 power 9, 2 power 11. 2 power 11 is equal to 2 KB. 2 KB. So 2 KB chunks will be stored in memory. So how many, what is the size of physical address space? Listen to me carefully. What is the size of physical address space? See the problem. The size of physical address space, the size of physical address space is 36 bits. 36 bits. So in this 36 bits of address space, physical address space, we are going to store pages of size 2 KB. So how many such pages can be stored in the whole address space? How many such pages can be stored? 2 power 36 divided by 2 power 11. Are you getting my point? If I keep on storing, how many such pages in the entire physical address space I can store? 2 power 11. Are you getting my point? Because the pages, the page chunks or page tables of pages of the page table will be stored in memory. So 2 KB, 2 KB, 2 KB कितने आप store कर सकते हो? 2 power 25. That means each chunk will be addressed with how many bits? Each chunk will be addressed with how many bits? Each page of the page table will be addressed with how many bits? 25 bits. मतलब अगर ये concept अभी भी clear नहीं है तो एक और example लेकर आपको समझाऊंगा. Let us say my memory has got physical address. Listen to me. Physical address is 36 bits. Listen to me. I am using partitioning technique. Partition size, remember, partition से समझेंगे. Partition size is 2 KB. 2 KB. So my question is, so this entire physical address space, which is addressed with 36 bits, is divided into partitions of size 2 KB. Then what is the address of the partition? I am asking you, what is the address of the partition? Meaning, how many bits of address will be needed to refer one partition? How many bits of address will be needed to select one partition? So memory size divided into partition size will give me number of partitions. So कितने partitions बनेंगे? 2 power 36 divided by 2 power 11, it is equal to 2 power 25. So my memory will have 2 power 25 partitions. Am I right? My memory will have 2 power 25 partitions. Each partition of size 2 KB, and every partition will be addressed with how many bits? 25 bits. 25 bits. उसी तरह ये concept है यहाँ पर. When these chunk I am going to store in memory, So every partition, every chunk, every page of page table will be addressed with how many bits? It will be addressed with 25 bits. 25 bits. So that is the point. So this address will be stored. So you may say, sir, this part entry size you are taking 4 bytes, but you are storing only 25 bits. Yes, because I can store other information with regard to that page. I can have other information. Page table entry contains the address of that page in the memory plus other information. So 25 plus 7, 32 bits. Let it be 32 bits. That is the point. So therefore 25 bits. Now come to the next level. So this page, this chunk, listen to me. This chunk will give me the address of next level page. Next level page. Right? These are the page of the first level page table, page of the second level page table, page of next level. Right? How many bits are used to index into it? Given here. Again 9 bits. Again 9 bits. So that means this will again have 512. Entry size is 4 bytes. तो इसकी size भी बनेगी 2 KB. तो इसका भी एड्रेस क्या होगा जो यहां पर आप स्टोर करोगे? This will also be 25 bits. Are you getting my point? ये भी 25 है, ये भी 25. This is also 25. This is also 25. Because 9 bits and 9 bits are used. This is a page of the actual page table that contains the frame number, boys and girls. This contains the frame number in which the page of the page that is 4 KB size is present, right? So this is 12 bits. So that is what I have offset D, 12 bits. Because this is pointing to the page of size 4 KB, real page of virtual address space, right? So 12 bits are used. So 12, that is 4 KB into 4 bytes. Total size of this will become 4 KB into 4, 16 KB. So this is actual frame number, 12 bits. So this is containing the address of this. That means how many bits will be needed to select a chunk of this in the physical address space. That is the meaning of it. So therefore the answer for this will become this is 25, this is 25, and this is 24 bits. Because the physical address space 2 port 36 divided by the frame number is not 12 bits. 12 bits is used to index into it. Frame number is how much? 2 port 36 divided by 4 KB, 2 port 12, 2 port 24. So frame number is 24 bits. Frame number is 24 bits. This is 24. 12 bits are used to index into this 12 bits. I'm sorry, I drawn it wrong. This frame number is 12 bits are used to index into it. This frame number is actually required to index into this. So this frame number is 24 bits. So this is 24 bits. So 25, 25, 24. 25, 25, 24. So that is the concept of this question. So therefore the answer it comes out to 25, 25, 24. एक और एक वर्जन है जहां पर अगर आप मान के चलो एक particular architecture, some people say that the physical memory will be physically divided into frames. अगर आप physically divided into frames होगा, then the answer will become 25, 25, 25. 25, 25, 25. अगर physical memory frames divide नहीं होंगे, then this is the concept which you have to apply. So this is the total overall concept. जो questions मैंने छोड़े हैं as a homework, please work out them as a matter of practice. और मेरा channel है Telegram channel t.me/Khaleel Sir Gate. You can DM there and try to seek clarification for doubts. Try to seek clarification for doubts. ठीक है? So that is what I have from my side, and this is a small information with regard to the batches. If you are interested in future about at the Unacademy platform, उसके बारे में information है यहाँ पर about the various batches. It's just for there is a batch, it seems by name Ummeed batch starting from 9th February. So you can see the details on the app and you can see the code also. There is another batch by name Sangram starting from February 9, both English, and this is for DA, I suppose. This is for DS and AI. So that is what I have from my end, boys and girls. So I wish you all the best for your forthcoming exam on Saturday, either session 1 or session 2. Okay. And I expect that you are going to perform very well. You are going to do well in the exam, and Share your experience after the exam. Don't try to get disheartened. Have a very comfortable sleep before the in the night before the exam, and one day before, you please don't forget to visit the examination center compulsory, and write it comfortably. Try to attempt the gate paper in 2 or 3 passes. Pass 1, take up those questions which can be answered in order of one time. Pass 2, take up those questions which can be answered in order of polynomial time. Pass 3, try to take up those questions which can be solved in order of exponential time. Mean that require a great amount of thinking, great analysis, good analysis. ठीक है, ये आप देखिएगा. And lastly, never ignore the fact that there may be some questions which are totally like undecidable or NP hard, NP complete. So don't try to take up such questions and go into negativity or negative marking. So be calm, be peaceful, and take up the questions and solve it. So once again, thanks a lot from your side for the patience that you have shown during the session, and I expect that you really enjoyed the sessions and the teaching. So we'll meet again maybe on Saturday after the exam to take up some questions which have appeared, which are memorized questions given by the students, and we'll try to work them out. Okay. So thank you so much, boys and girls. Take care. Good night. Thank you so much.